Hello, hello. computing, but this time we change it to cloud and edge. Okay. Technology, the way it moves. If you want to be application developer, or if you want to go for any utility, or sometimes people are having very weak or less programming skill. This is the domain which provides a good opportunity for the job. So what is a data center? Have you heard of, you are using this term, what is a data center? These are very live things, you see, to keep the with the pace of the things we used to data. The latest updates as per the when only my students teachers there. Wild entry because of the cloud computing. Someone teaches 4 papers, someone sometimes very simple multiplication. Many of you even do not know how to your skill set you observe, and things you are through the skill development. One of my friend who was heading the Asia Pacific. Hello.
Slash A9 capital T small I T. So two reasons, people. So till yesterday we tried writing our own code for a particular method or a particular library, right? We wrote our own code for matrix factorization. मैं बैठ ही जाऊँ ना? Okay, I will sit because so this the camera doesn't like me when I stand. Now we can, there's this only so much we can do in writing our own code. We can go about and write code for every particular neural network which is there, or at least one of them, but it will be time consuming. And this is where Python is cool in providing us a number of libraries to use. So we'll today onwards we'll start using the inherent learning libraries of Python. Okay. So in the first hour or so, I will tell you the problem why we started looking at from a semiconductor engineering point of view. So a business problem. Then in the second hour we'll run through the kind of classifiers we can try with the first order classifiers. We'll look at random forest, we will look at gradient histogram boost, we'll look at simple decision tree. Okay. Then after lunch, hopefully after lunch we will again we'll start coding this thing, and if we get time we will show you the result of our study which we did previously on this problem. Okay. So today the coding part will be relatively easy. The reason we have given you that link is there's a folder called slides there now, where I have placed all the slides including today's slides. So you will need today's slide for going back and forth, because I'm not going to give you any code today. So you're writing the entire code from scratch today. Okay. The second thing is, in your sugar folder you will see a large number of other databases which are there, and if we get time, so we'll start by looking at the semiconductor yield database, but those who complete it quicker will also look at agricultural databases, things like crop prediction and crop recommendation databases, to see if we can do any of that. Okay. So first hour is going to be very electronics lecture. So all those computer science people who hate going to electronics lectures in our first year, or even in second and till which year do computer science people learn basic electronics circuits and other things? Second year also you are running digital electronics, right? And then you have to do microprocessors at some point of time. Good. So you know some of it. So the paper to read for today would be a short paper. It's just a 4-page long paper. It's written by Rebecca Bush, one of my PhD students. And what we looked here was, can we use machine learning and parameter optimization to predict yield in semiconductor production? Now before we delve into the machine learning part,
to many.
Somebody still wants to teach from another room. So there are professors like me who are lazy teachers, who can continue. There are professors who really want to force you. This is my favorite topic and you have to learn this topic. So before we understand why yield is important, so you might have seen single chips in your laboratories, or how many of you have opened a computer? No? One person? What about bachelor students? You have never opened a computer inside? So are you all in engineering colleges or typical universities where you also have humanities departments? You also have humanities department, right? So I don't know if I can say this publicly. My standard advice for engineering students used to be, don't open your machine in case you make it go bad. Make friendship with somebody from humanities who has no idea about computers but has bought the fanciest computer in the world, right? 2 days later they will know something is not working, and that's the time to apna haath saaf karne ka. Laptops I will advise not, but desktops you should certainly open and peek around what's going on. Actually, you know what? Can one of the master student help me? If these guys have never seen inside a computer, can we try to get, in that machine, in that high voltage room, there are many old computers. For an old computer which nobody uses. Okay. I'll talk to Dr. Mukherjee if we can lay our hand on an old machine, which they will be happy to give to me so that I don't break it. For any machine, we'll open it and see what's inside. Right? My standard advice earlier used to be, become a better half of somebody from humanities department. Then they will trust your machine and phone to you. If you can fix it, the relationship continues. If you can't fix it, it goes down. But hey, it's humanities department, you can take some risk with them. It's vital for a computer scientist to know what's charging our power, what's powering the entire activity. Okay. So if you open inside of a computer, you will see a number of chips all doing different things. One of the big ones will be a microprocessor. There might be solid state drives, there might be voltage controllers, and so on and so forth. And I think we will open a machine today. If nothing else, I'll be opening this machine. So if you can't find a machine to me, we are opening the office computer here. It's a Dell machine, so I'm sure I have opened enough of them to show it's not going to stop working. The way these chips are manufactured, they're generally made on a wafer, which is a semiconductor base. And we have large number of chips manufactured on the same wafer. Okay. But as luck goes, not all of the chips are going to be functional. How many of you have made roti? 2%. You guys will be dead if you go anywhere. Okay. Look, the master students have learned to make it. You never make the rotis of the same dimension, even if you have been too experienced. Our mothers will disagree to the fact, मेरी सारी रोटियां perfect होती हैं. But coming back to wafers, because we have a large number of chips, some of these may or may not work. Now for a production company, the ones who don't work are pure loss, because making of a chip process takes a lot of time, energy, and cost. So say we have a wafer, it's a circular wafer, and each one of these are individual chips. And we have 60% yield, that means 40% of my chips are going down the drain. Now for the next hour, we will see why these things can happen, to give you a complexity of the problem as to why it's difficult to predict what's going to happen. Why we cannot look just at process parameters and say कि अगर temperature ज़्यादा हो गया था या pressure ज़्यादा हो गया था इसलिए चीज़ें खराब हो गई. Okay. Now the process yield of foundries is a very closely guarded secret. So I worked with 2 foundries, and if I tell you today that, they will kill me. So no foundry ever tells to the white side what is my process yield, what percentage of my chips will work. A good foundry in this high scale process will aim for something like 90-95%. But depending upon the device and the customer you have, it could be even lower. If it's a new foundry, the yield will be lower. The yield improves over a period of time because we know what makes the things click. And this is one of those dark arts of fabrication as to what is the exact sweet spot of various temperature pressure profiles which leads to a good device working. Of course there are equations, but real world has got equations and lots of other factors. And there might be a tiny little movement in the building, tiny change in air conditioning, tiny change in liquid nitrogen supply, or a bit of dust particles which could make our life very miserable. I was talking to you about the size of transistor the other day. So let's ask this question. This is again a fundamental question. So because these transistors are very tiny, we can't afford for dust particles because dust particles are also small. Right? So we make these transistors in something called clean rooms. And this is the place where we wear our spacesuit uniform to go inside. Okay? And the clean rooms are classified based on number of dust particles per cubic centimeter allowed. Because we can't get 0. 0 is almost space, and we're not making it in space. So if a cubic centimeter of air has 1,000 dust particles, we call it a class 1000 clean room. We have class 100 clean rooms, and for very advanced processes, let's say less than 65 nanometer, we also have class 10 clean room. So you allow 10 dust particles per cubic centimeter. Now, there's one more clean room which some of you might have seen. If you have not seen a semiconductor fabrication clean room, you have seen an operation theater. At least हिंदी ड्रामा देखे होगे तो कोई ना कोई आदमी ऑपरेशन थिएटर के बाहर वेट करता जरूर मिलता है, ठीक है. वो भी एक क्लीन रूम है, काफ़ी साफ रखते हैं. Do you know how many dust particles are allowed in operation theater? So I'm just comparing our clean room to that clean room. About 10,000, 10 to 100,000. Generally 100,000 is good. So a place where we build human beings, we take less care than where we make our chips. So my clean room are sacrosanct. Nothing goes in. Even I will not go in without changing myself completely. Okay. Though we must confess, we have been once in the clean room without covering our face because was in photo lena tha to go into the display. And all of us wearing face masks and covering ourselves, well, it doesn't look very good on photographs. Though that's a different story. The lab engineer had a fit looking ki mask hata diya. See, my apologies. Now, so one question is, dust particles can destroy my transistor performance. If they fall on any one of the layers, I'm done for. So we generally use liquid nitrogen for cooling, and we use a lot of significant resources to clean the room. I mean, right now this room is fairly clean, but we are looking at around 1 million dust particles per cubic centimeter in this room. Okay, and compared to what we have outside, it's perfectly fine. Oh boy. My font sizes have gone completely bonkers going from Mac to this, but I guess it's still readable. Okay. So what we will do is, for first half an hour, we will see how is a chip made. Now, all of you know the very fundamental unit of electronics, the inverter. Have you come across inverter? Basically, you give 1, you get 0, you get 0, you get 1. It's as simple as that. Okay? And that is the circuit counterpart of an inverter in a MOSFET process. We have an NMOS type transistor, we have a PMOS type transistor. They are put in series. You have to provide input at their gates and you take output at the drain. And we have power supply on top, ground on bottom. Something as simple as that. Okay? That's how is the vertical cross section of a physically made inverter looks like. Most processes these days are a P substrate process. So we take a semiconductor, mostly silicon, but there are people who also make it from gallium arsenide or silicon germanium process and others, but mostly silicon. And typically we start with a P type substrate. So, and here we make an N well to make the PMOS transistor, because PMOS transistor has got different. And then we will have diffusion. So that's our transistor here. 2 N-type diffusion, a gate contact, and a substrate contact. You know, something to connect to substrate, something to connect to the gate, and 2 diffusion. And the PMOS transistor is now sitting in an N-well, and you have metal connections. The blue lines are your metal, which are connecting between this terminal and this terminal here. Okay, so that's a single transistor. Remember, in a normal high-end processor, we are now looking at about 1 billion to 10 billion of these devices. Okay, so we'll now go across saying what it goes in making one inverter, for you to give an idea what goes when we are making 1 billion of these in parallel, how many things can go wrong. Okay. So a bit of drill, we are going to do a bit of material sciences. The beauty of what I used to say, that the beauty of being an electronics engineer is I need to know one element in the periodic table, which was silicon. And I know everything about silicon, but I have no idea about anything else. The beauty of computer scientist was to say, periodic table वो कौन सी बला है? कोई classification करना है क्या उसमें? So, this is what we need cursory. We need a P-type substrate. उसको बनाने के लिए some sort of intrinsic semiconductor चाहिए और कुछ dopant diffuse करने होंगे. But ये generally बना बनाया आता है. When we start a cleaner process. P type substrate बना बनाया आता है, we don't physically try to make them. इसमें हम लोग NWEL बनाएंगे, which means कुछ डिफ्यूजन है, आयन इम्प्लांटेशन करना होगा डोनर्स के साथ, राइट. सो पहला जनरली नीचे से बनना शुरू होता है, राइट. सो यू स्टार्ट विद अ सबस्ट्रेट एंड स्टार्ट मेकिंग फ्रॉम टॉप बॉटम. इसमें फिर सोर्स और डिफ्यूजन बनाएंगे, एन टाइप सोर्स एंड और पी टाइप सोर्सेस. और इनकी डोपिंग ज्यादा होती है.
Please remember the
P type
definition.
substrate here, the dopant of P plus will be heavily diffused, and that's why it's written as P plus. Similarly, your N type diffusion here will be more diffused than N well. So ऐसा नहीं है कि same process repeat कर सकते हैं. उसके बाद थोड़ा एक dielectric लगाना होगा to form the gate. You can see the small dielectric which is just covering the gate. और जब हमने गेट लगा दिया, then we need a thick oxide, silicon dioxide, to separate structures. Remember, अगर इलेक्ट्रिक शॉर्ट होगा तो हमारा पूरा का पूरा चिप गया. So good dielectric वायर्स के बीच में शॉर्ट करने के लिए. उसके बाद हम गेट बनाएंगे. गेट तो हमने बना दिया, गेट को इलेक्ट्रिकल कॉन्टैक्ट भी देना हो. Now this is a very fun thing. So आप लोग जनरली वर्ड सुने होंगे MOSFET, like metal oxide semiconductor field effect transistor. मेटल यूज नहीं होता टू मेक द गेट. इट्स एन ओल्ड नॉमेनक्लेचर जो चला आ रहा है, तो बस कौन बदलने जाए. वी नाउ यूज पॉलीसिलिकन. ओके, तो मेटल की जगह हम लोग पॉलीसिलिकन इस गेट कांटेक्ट में लगाएंगे. बट बाकी सब चीज़ को कांटेक्ट करने के लिए मेटल यूज होता है. हिस्टोरिकली हम लोग एल्यूमिनियम यूज करते थे, अब हम लोग कॉपर यूज करते हैं स्मॉलर जियोमेट्री प्रोसेसेस में. ठीक है. The other materials, the other better conductors are gold and silver. Gold बड़ा बुरा conductor है, diffuse करता है silicon में. But we do use gold for electrical contacts to the chips when they are made. And this is the mistake which I did when I got married. My mother said कि शादी हो रही है, कुछ gold का gift लेते आना wife को देने के लिए. लास्ट डे था, भूल गए थे, तो आई जस्ट टुक ए चिप सेट. प्योर गोल्ड है, कॉन्टेक्ट्स तो गोल्ड है ही. माय वाइफ स्टिल हैजंट फिगर्ड आउट किसका करना क्या है. एंड एज ए इलेक्ट्रॉनिक्स इंजीनियर आई ऑफन आई एम रियली अनॉयड एट गोल्ड शॉप्स. आई मीन आई नो पीपल डू यूज गोल्ड ज्वेलरी. दे इंक्रीज द गोल्ड प्राइसेस. हमें गोल्ड चाहिए टू मेक द कॉन्टैक्ट्स. वो महंगा होते जाता है हर साल, क्योंकि लोग गहने खरीद रहे हैं, और गहने खरीद के you're not doing anything, right, on your jewelry, but otherwise it does nothing, right. कपड़े पहन रहे हो तो कम से कम कोल्ड से बचा रहा है, but this is just wastage of natural resources. Okay, I know it's a currency, people use gold thing as a currency, but anyway, so this was a side view of a transistor, of an inverter. Vertical cross section मारते हैं चिप का. अगर ऊपर से देखें हम तो something like this दिखेगा. Okay, we have got ground contacts and we have got these my contact for the gate. Two type of transistor, N type of transistor, P type of transistor, and you can see the well around P type transistor, and then the contact for electric. So the blue lines are metal. The hatched, is it orange or pink? You know, this line, that's polysilicon. The green is an N-type diffusion. Brownish orange is the yellow P-type. I'm fairly color. It's color classification is a difficult job for me, and you can see. So I've got red, and everything else is pretty much the same color for me. Okay. So that's what the chip designer gives to the foundry. ये वाला मुझे बनाना है, आप हमें बना के दीजिए. Okay? So if you ever go to a chip design studio, you'll see a number of layout engineers literally painting on their screen. यहाँ पर ये transistor है, इससे ये contact हो रहा है. ठीक है, अब automated process भी use करते हैं, but analog design engineers still do color painting. Okay? So this, I think once my 4-year-old son visited my lab and I took him around seeing कि मेरे students क्या करना है, and of course they were doing layout. And घर जाके मम्मी ने पूछा क्या करते हैं, अरे कुछ नहीं करते हैं मम्मी, जो मैं स्कूल में करता हूँ ना क्रेयॉन से पेंटिंग, वो कंप्यूटर पे पेंटिंग कर रहे थे. And we do some things like that. So now each one of these layers जो हमने draw किए हैं उनको separately बनाते हैं and they become a different mask. So first thing you do in a layout is separate it into different layers जो हम बनाने वाले हैं. So as you can see, if I break down the layers, each one of them becomes different things. You have an N-well, ये कहाँ कहाँ N-well बनेगा, polysilicon, diffusion, N plus diffusion, P plus diffusion, the contact cuts कहाँ contact करेंगे, and then metal points. Guys, for all electronics and computer science engineers, fabrication can become very very boring very very quickly. इसलिए हम लोग हर चिप डिज़ाइन का पहला लेक्चर यही करते हैं. अगर ये सर्वाइव कर गए तो बाकी सब एग्जिस्ट कर जाओगे. बट आप लोग को हम इसलिए कर रहे हैं so that to get an appreciation of how things can go wrong and where are many places where things can go wrong. Okay. Other buzzwords to know. एक फीचर साइज होता है. हर फाउंड्री का एक जो स्केल होता है उसमें एक फीचर साइज नंबर कहा जाता है. इट्स ए 0.35 माइक्रोन प्रोसेस which means the smallest, well, originally it used to mean smallest dimension transistor. It no more means smallest dimension transistor. It means the smallest feature which you can make in the process. So the smallest feature you can make is 350 nanometer or a 22 nanometer or a 5 nanometer. And smaller is the feature size, more is the transistor I can put in this. Okay. अगर ज़्यादा ट्रांजिस्टर बनाना या तो हम अपना चिप बड़ा बनाएं या फिर चिप सेम साइज का रखें and small transistor घटाएं. Smaller is the transistor, it also generally means it will deal with smaller voltage और उसकी पावर और लो पावर होगा. पावर घटेगा, फ्रीक्वेंसी ऑफ ऑपरेशन बढ़ेगा. Okay. The other thing which is tangible is the wafer size. कि हमारा जो standard wafer है, जो round wafer है, कितना बड़ा है. एक वेफर में हम कितने चिप्स बना सकते हैं. हिस्टोरिकली 6 इंच या 8 इंच वेफर यूज़ किया जाता था, 150 मिलीमीटर या 200 मिलीमीटर. Yes, 8 inch does not mean 200 millimeter exactly, but exact division करने लगे तो दिक्कत होगी. आजकल 300 millimeter wafer is the standard, and there is a move to 400 millimeter. Okay, to give you an idea कि एक वेफर कितना बड़ा है, अगर हम 300 millimeter वेफर ले रहे हैं 122 नैनोमीटर, आज से करीब 5 साल या 5 साल से भी ज़्यादा पुरानी प्रोसेस, अभी भी fairly quite a lot यूज़ होती है. We are forming 10 to the power 12 transistors. आज हम लोग 2 ट्रांजिस्टर बनाने की चीज़ देखेंगे, एक NMOS और एक PMOS. So generally we are putting 10 to the power 12 transistors. Generally speaking किसी एक चिप में इतने ज़्यादा ट्रांजिस्टर्स की कभी ज़रूरत नहीं पड़ती. तो हम लोग क्या करते हैं, एक वेफर पर कई चिप्स बनाते हैं, बाद में उस वेफर को डाइस करते हैं, काटते हैं और ईच चिप को सेपरेटली पैकेज करते हैं. There are applications जहाँ हमें बड़ा चिप बनाने की ज़रूरत पड़ती है. When you think of a place where I will need a big chip, इतना बड़ा कैमरा कहाँ देखा है भाई? 300 millimeters diameter is quite big. 8 inch. So think of 8 inch. It's almost this big. That's the radius, right? And 12 inches, well, a little bit bigger. So मेरे वर्ल्ड में, कैमरा वर्ल्ड में होता है, बट इट्स नॉट द स्टैंडर्ड कैमरा जो आप यूज़ करते हैं. कभी खास करके डिजिटल एक्सरे देखा हो आपने, ह्यूमन बॉडी साइज एक्सरे, तो एक्सरे के साथ ऑप्टिक्स बनाना बड़ा मुश्किल काम है. तो जनरली एक्सरे को हम लोग डायरेक्टली एक्साइट कर. सो नॉर्मल कैमरा में आपने लेंस लगा दिया, फील्ड ऑफ व्यू इतना बड़ा है, छोटे कैमरा पर आप लेंस लगा के कर सकते हैं. यहाँ पर फील्ड ऑफ व्यू ह्यूमन बॉडी साइज है, तो आपको ह्यूमन बॉडी साइज ये बनाना, और वो भी एक चिप में नहीं बनेगा. तो जनरली वी मेक वन चिप ऑन ए वेफर और कई सारे वेफर्स को टाइल करके एक ये बनाते हैं. बट मोस्ट प्रोसेसिंग एंड मेमोरी विल जनरली लीड टू अ लार्ज नंबर ऑफ चिप्स पर वेफर. और ये इन ज़रूरत इसलिए भी है क्योंकि चिप बनाना बड़ा महंगे का काम है. वी आर लुकिंग एट लीस्ट $1 billion और $10 billion इन्वेस्टमेंट जस्ट टू स्टार्ट. तो हमें पहले चिप के लिए इतना खर्च पड़ेगा. एडवांटेज यह है कि पहला चिप बनाइए या 100 million चिप बनाइए, कॉस्ट रिमेन्स द सेम. सो कॉस्ट पर चिप गोज डाउन. ओके, गुड. सो वेफर का थिकनेस जनरली फिक्स्ड होता है डायमीटर के साथ. सो ए 300 millimeter वेफर विल बी अबाउट 775 माइक्रोन थिक. सो 7 hair साइज थिक अपने ये लेते हैं. The other beauty of the process is कि जो एक लेयर है अगर मान लीजिए हम मेटल लेयर डिपॉजिट कर रहे हैं तो सारे 10⁻12 ट्रांजिस्टर्स का मेटल लेयर एक साथ डिपॉजिट करेंगे। अगर डिफ्यूजन कर रहे हैं तो सारे ट्रांजिस्टर का डिफ्यूजन एक साथ होगा, मेरे चिप का, मेरे बगल वाले चिप का, एंड सो ऑन सो फोर्थ। अदर थिंग वी जनरली डू कि एक वेफर पर हम लोग एक ही तरह के चिप बनाते हैं। जनरली देयर आल्सो मल्टीपल प्रोजेक्ट वेफर्स जहाँ पर हम डिफरेंट कॉर्नर्स में डिफरेंट दिस इज हाउ वी यूनिवर्सिटीज कैन डू चिप रिसर्च। क्योंकि हमारे पास तो उतने पैसे हैं नहीं, $1 million टू स्पेंड ऑन वन PhD स्टूडेंट थीसिस थोड़ा ज़्यादा महंगा होता है, right? और उसके बाद PhD स्टूडेंट ने कोई एक मिस्टेक कर दी तो सारा का सारा पैसा पानी में गया ना। एक इंडस्ट्री में जनरली चिप्स को क्रॉस चेक करने के लिए काफ़ी लोग होते हैं, और जब हम ट्रेन कर रहे हैं अपने लोगों को तो फिर एक ही स्टूडेंट डिज़ाइन से लेआउट सब कुछ करते हैं। okay? तो इसमें मल्टीपल प्रोजेक्ट वेफर्स होते हैं, हर लोग को अपना अपना कॉर्नर मिलता है जहाँ मेरे 20 चिप बनेंगे, 20 चिप किसी और यूनिवर्सिटी के, किसी और कंपनी के, एंड सो फोर्थ। इट ऑल्सो यूज फॉर अगर प्रूफ ऑफ कॉन्सेप्ट टेस्टिंग करनी है कि कैसे चलेगा या नहीं चलेगा तब के लिए। सो लेट्स सी हाउ इट हैपेंस। और अगर अभी तक बोरिंग हो रहा था तो अगला आधा घंटा और सुलाएगा आपको, जो कि जनरली इट्स क्लासिक्स होने वाला लेक्चर। सो माई अपॉलॉजीज इन एडवांस, बट यू डू नीड टू अप्रिशिएट where things can go wrong। तो पहला काम हमें ये करना है कि हम P टाइप सबस्ट्रेट से शुरू कर रहे हैं, और इसके पहले हम कुछ बनाएंगे। हम उन एरियाज जिनमें नहीं बनाएंगे उनको प्रोटेक्ट करने की कोशिश करेंगे। ओके, सो पूरा सबस्ट्रेट ले लिया, यहाँ पर ट्रांजिस्टर बनेगा बट बाकी जगह तो कुछ नहीं बनेगा ना, तो उसको शील्ड करना है हमें। तो शील्ड करने के लिए हम we start with we put a protective layer, सिलिकॉन डाइऑक्साइड का प्रोटेक्टिव लेयर जनरली लगाते हैं। इसका एडवांटेज है सिलिकॉन ऑलरेडी है, उसको ऑक्सीडाइज कर दीजिए टॉप सरफेस तो ऑक्सीडाइज हो जाएगा। तो ऑक्सीडाइज करने के लिए पहला काम करते हैं कि हम एक फर्नेस में 900 to 1200 डिग्री सेल्सियस पे हीट करते हैं, वेफर को गर्म किया हमने। ओके, और उसके बाद आइदर यूजिंग ऑक्सीजन या वाटर वेफर टॉप लेयर को ऑक्सीडाइज करते हैं। टेम्परेचर बढ़ा हो, ये हो, वन ऑफ द ऑक्साइड फॉर्म हो जाएगा। H2O के साथ ऑक्सीडेशन जल्दी होती है, बट देन आपको हाइड्रोजन बचा हुआ उसको निकालने का एक प्रॉब्लम होता है। सो फर्स्ट थिंग फर्स्ट, टेम्परेचर पता नहीं है कि एग्जैक्ट 900 रहा होगा, यस। और ईच पॉइंट पर हम तो पूरे वेफर को हीट कर रहे हैं ना, एक फर्नेस में डाला है हमने, ईच पॉइंट पर क्या टेम्परेचर गया है वेफर का, थोड़ा डिफरेंट आ सकता है। ओके, कल हम लोगों ने मिसमैच की बात की, एक चिप पर दो ट्रांजिस्टर सेम नहीं होते, इसलिए भी सेम नहीं होते कि दोनों को एक ही प्रोसेस नहीं मिला है। सो हमने ऑक्सीडाइज कर दिया। अब हमें वो एरिया आइडेंटिफाई करना है जब हमने सिलिकॉन डाइऑक्साइड बनाया, सिलिकॉन डाइऑक्साइड के ऊपर हमने एक फोटोरेसिस्ट लगाया ताकि चीज़ें मिक्स कर जाए, राइट। या फिर अगर आपने शायद स्कूल में एक्सपेरिमेंट किया हो कि एक बूंद वाटर कोई कलर की डालो और नीचे वाले चीज़ को रोटेट करो तो कलर स्प्रेड आउट कर जाता है यूनिफॉर्मली, तो एसेंशियली वही काम करते हैं। एंड जनरली देयर आर पॉजिटिव एंड नेगेटिव फोटोरेसिस्ट बेस्ड ऑन कि किस रीजन को हम इल्यूमिनेट करना है। ठीक, तो हमने फोटोरेसिस्ट लगाया, अब फोटोरेसिस्ट के ऊपर मास्क लगाएंगे। सो मास्क इज गोइंग टू टेल मी कि इस वाले रीजन में हम कुछ बनाने वाले हैं, एंड दिस इज व्हाट डिटरमाइंस द फीचर साइज। कौन सा छोटा, सबसे छोटा प्रोसेस लगा, हमारा मास्क कितना छोटा हो सकता है, उसके अनुसार से हम उतना छोटा डिवाइस बना पाएंगे। Protect rest of my chip, photoresist will not be able to handle the brute forces जो हम लगाने वाले हैं। हैं और फोटो लिथोग्राफी कर सकते हैं, तो आप कोई भी चिप बना सकते हैं. एंड चिप इंडस्ट्री इज़ वन ऑफ द मोस्ट, अपने आप को बहुत प्रोटेक्ट करती है क्योंकि कंपटीशन ज़्यादा है, और एक बार आपने जो रेसिपी जान गए तो फिर कोई भी कर पाएगा. यू डोंट वांट टू गिव अप योर रेसिपी. तो अब हम साइलेन गैस डिपॉजिट करेंगे यूजिंग समथिंग कॉल्ड केमिकल वेपर डिपोजिशन, और फिर से वही प्रोसेस लगाएंगे, राइट. फिर से मास्क हम लोग लगाएंगे, मास्क के ऊपर इसे, और फिर बाकी चीज़ों को हटाएंगे, और ये प्रोसेस टाइम एंड अगेन रिपीट होगी. सो दिस विल लीड अस टू ए गेट, और फिर गेट के ऊपर हमें मेटल कांटेक्ट करने हैं, तो फिर से वी विल कवर एवरीथिंग विथ ऑक्साइड, कवर एवरीथिंग विथ सिंक, और सो ऑन सो फोर्थ. सो अब हम लोग जब गेट हमने बना दिया, तो गेट के डिवाइस वर्क्स इज बिकमिंग अ वेरी कॉम्प्लेक्स इंटरैक्शन, वो हमें नहीं पता है. तो एसेंशियली हम क्या करते हैं, वी कलेक्ट ए लार्ज नंबर ऑफ टाइम सीरीज डेटा. सो गैस सेंसर का फ्लो का सेंसर, इट इज कलेक्टिंग ए ह्यूज अमाउंट ऑफ टाइम सीरीज डेटा. नाउ दिस डेटा इज टू लार्ज फॉर एनी डायरेक्ट इवैल्यूएशन.
Both start.
Okay.
So we must take a particular domain which is rising up. हाँ? अब हमको ये जोन में
फ्यू सेकंड में मुझे याद दिलाता है क्या कि आप लोग बहुत बोल रहे हैं, चौबे जी अब बंद कीजिए. नहीं लग रहा है कि इट गोज ऑन एंड ऑन. इट्स लाइक डिराक डेल्टा फंक्शन. जीरो रहता है, जीरो रहता है, ट्रैक, फिर जीरो जीरो.
Deliverson.
So even
So this is the
before the data
transition you
comes
see.
to us, there are things called fault
The
detection
cloud
and
shift from
classification
2025,
FDC
it has
system.
completely shifted. It starts with a bit of the niche. So these are the points. So this is a business innovation,
जी, हम भी पढ़ा
centralized
लें.
and distributed cloud, international multi-cloud and fusion. So then
This one is proving to be a bit more. हाँ, क्लाउड चला गया. एक्चुअली क्लाउड में लेक्चर हो रहा था ना, क्लाउड तो सभी जगह जा सकता है. तो FDC सॉफ्टवेयर जो प्री प्रोसेसिंग है, वो ऑलरेडी क्वाइट अ लॉट ऑफ टारगेटेड कॉम्प्रेशन उसने कर दिया है, क्योंकि टाइम सीरीज डेटा बहुत बड़ा है, राइट. एंड सेमी ऑटोमेटिक प्रोसेस मॉनिटरिंग कर लेता है. इसके बावजूद हर वेफर और हर प्रोसेस फ्ले के लिए वी एंड अप हैविंग सेवरल 100 डिफरेंट पैरामीटर्स. ओके, गुड. So, अब हमें इन 100,000 different parameters से what would be nice to see if we can tell yield क्या होने वाली है, कितने चिप्स इस प्रोसेस पर. अगर हम 100 चिप्स बनाएंगे तो क्या 99 उसमें से काम करेंगे. एंड इट्स एक्चुअली, काम करना इज a very strange word. Is are they going to be within my specification? And a very simple specification is the clock speed. अगर हम प्रोसेसर बना रहे हैं और 3 GHz क्लॉक हमें देना है, तो will they work at 3 GHz or will they work at 2.6 GHz? तो दो काम हम ये कर सकते हैं कि जो हमने 3 GHz बनाया, जो 3 GHz नहीं दिया उन सबको फेंक दें, या फिर ये कर सकते हैं कि अगर उसमें से कुछ 2.6 GHz बने तो उनको थोड़े सस्ते में बेचें मार्केट में. जनरल मैन्युफैक्चरिंग प्रोसेस में होता है कि थोड़ी पुअर यील्ड वाली चीज़ों को हम एंड दिस व्हाई यू ऑफन हैव चिप्स ऑफ डिफरेंट क्लॉक स्पीड एंड स्लाइटली डिफरेंट परफॉर्मेंस. तो यील्ड को हम जितना हाई होना चाहते हैं, नंबर ऑफ चिप्स ऑन ए वेफर सेम, अगर यील्ड हाई है तो ज़्यादा चिप्स काम करते हुए दिखेंगे. तो दो प्रॉब्लम आता है हमारे साथ. एक तो है कि हमें यील्ड प्रेडिक्ट करना है, इतने सारे सेंसर डेटा हुए, इससे क्या यील्ड होने वाला है. That way we don't have to go and test each chip. दूसरा ये है, can we do the reverse process, कि हमारा yield इस कारण से खराब हो रहा है, इस पर्टिकुलर सेंसर डेटा के कारण खराब हुआ, तो उस प्रोसेस को जाके टेम्परेचर आप मॉडिफाई कीजिए. हम लोग कई 100 स्टेप्स के साथ जा रहे हैं, तो अगर ये वाला काम कर सके, दैट हेल्प्स ए फाउंड्री. द अदर थिंग याद रखिए कि डायरेक्ट कोरिलेशन हमारे नहीं पता है. वी आर काइंड ऑफ गेसिंग. तो जितने प्रोसेस हम मेजर कर रहे थे, वी आर नॉट मेजरिंग द डिवाइस, वी आर मेजरिंग द एनवायरनमेंट इन विच द डिवाइस इज बीइंग मेड. तो एनवायरनमेंट वेरिएबल्स विल समहाउ बी रिलेटेड टू द डिवाइस परफॉर्मेंस. एग्जैक्ट कोरिलेशन क्या है वो नहीं पता है, और एक्चुअल यील्ड जानने के लिए फिर हमें ईच डिवाइस टेस्ट करना होगा, वो बहुत कॉस्टली प्रोसेस होगा, बहुत टाइम कंज्यूमिंग होगा, सो भी हमारे लिए प्रॉब्लमेटिक है. सो दिस इज आवर क्वेश्चन. जो हमने सेंसर डेटा कलेक्ट किया है, कैन दैट प्रेडिक्ट द यील्ड? एंड नाउ हियर आर टू क्वेश्चंस. एक है कैन इट प्रेडिक्ट द एक्चुअल यील्ड, कितने 99% है, 80% है, 60% मेरे काम करने वाले हैं. That's the harder question. The simpler question which we could ask, कि अगर हमें एक थ्रेशोल्ड लगा दिया है 90% से नीचे काम करने वाले जो भी चिप वेफर होगा उनको टेस्ट करने को, और उसके बाद भी डाइसिंग करनी है ना, काटना है, पैकेजिंग करनी है, हम नहीं करने वाले हैं. इट्स यूजलेस, इट इज गोइंग टू कॉस्ट टू मच. तो अगर वो भी हमें बता दे कि क्लासिफाई कर दे कि ये अच्छा वेफर है, ये बुरा वेफर है, और अच्छा और बुरा का हम एक आर्बिट्ररी लेवल बना दें, इसके ऊपर सब कुछ अच्छा है, अगर मैं 100 में से 90 चिप काम किए तो हमारे अच्छे, या फिर हम वेफर ये भी कर सकते हैं 100 में से 95 चिप काम किए तो हमारा वेफर अच्छा, नहीं तो हमारा वेफर खराब. तो इट लीड्स टू अ फेयरली सिंपल क्लासिफिकेशन प्रॉब्लम. सो दो बेनिफिट हैं, एक तो टेस्टिंग अवॉइड करेंगे, बट दूसरा क्वेश्चन अगर हम ये रिस्क करते हैं, अगर हम जितनी जल्दी हम बता सकें कि ये वाला वेफर खराब होने वाला है, उतना जल्दी हम प्रोसेस मैन्युफैक्चरिंग रोक पाएंगे, तो कुछ पैसे बचा लेंगे. सो द एक्चुअल वैल्यू ऑफ यील्ड इज द रिग्रेशन प्रॉब्लम. अगर हमें बताना है कि एग्जैक्टली हमने इतने डेटा सेट है, हमारा ह्यूज डेटा सेट है, और इससे हमें एग्जैक्ट यील्ड बताना है, इतने परसेंटेज आ रहा है, तो दैट्स अ लिटिल बिट हार्ड. दो कारण से हार्ड होता है. एक तो है कि one of the reasons why computer science has or deep learning has evolved so much recently, कि बहुत सारे open data sets हैं, right? MNIST है, fingerprint data sets है, number data, आप अपने नेटवर्क को जाके ट्रेन कर सकते हैं. इस फील्ड में कोई open data set नहीं है. So each company is having their own data set, और कोई हमारे data set पर काम नहीं कर सकता. यहाँ तक कि हमने भी जो पेपर लिखा है इस ऑन ए डेटा ऑफ ए पार्टनर कंपनी, उस डेटा को हम रिलीज नहीं कर सकते. तो उस कंपनी के इंजीनियर्स को छोड़ के और किसी को एक्सेस नहीं है, और हर कंपनी का अपना अपना डेटा सेट है. तो ऐसा हमारे पास कोई पब्लिक डेटा सेट जहां पर बहुत लोग मॉडल को वेरीफाई कर सके और कह सके कि ये वाला मॉडल सबसे अच्छा है, इसको ट्राई कीजिए. और जो हर कंपनी का डेटा सेट है, वो उन्होंने डेटा कलेक्ट करना शुरू किए थे बिफोर इवन डीप लर्निंग बिकेम ए फैशनेबल थिंग. चिप तो हम कई सालों से बना रहे हैं, तो हमारे पास बहुत सारा पास डेटा है, बहुत सारा अनस्ट्रक्चर्ड डेटा है, बस डेटा कलेक्ट करके रखा हुआ है. तो हाउ डू वी प्रोसेस दिस इज चैलेंज. द अदर प्रॉब्लम, गुड और बैड यील्ड, इज अ लिटिल बिट मोर स्टडीड, क्योंकि हमें सिर्फ 0 और 1 काइंड ऑफ आउटपुट चाहिए, वेफर ठीक या वेफर खराब. दैट्स ऑल्सो द स्लाइटली ईजियर प्रॉब्लम, बिकॉज हमारा नेटवर्क बहुत कॉम्प्लेक्स नहीं होगा. हमें एग्जैक्ट एक नंबर नहीं चाहिए, हमें एक बाइनरी टाइप ऑफ क्लासिफायर चाहिए. गुड. सो दैट इज all I'm going to teach you about fabrication and the problem, why yield is a problem and why we worked on yield. Okay. Depending upon whether the tea is ready and whether we have to take a break, we can continue to learn what are the algorithms which will be useful in predicting that yield. आज हम लोग algorithms का mathematical foundation नहीं करेंगे. आपने अभी तक देख लिया होगा कि मैं बहुत मैथ्स पढ़ाने के इंटरेस्टेड नहीं हूँ. मेरे पिताश्री मैथमेटिशियन थे, तो वो वाला जीन मेरे फादर के साथ अटक गया, मेरे में उतना नहीं आया. बट आई डू अंडरस्टैंड द कॉन्सेप्ट. हमने प्रोसेस कॉन्सेप्ट एक्सप्लेन किया है, और क्योंकि हम कोड नहीं लिखने वाले, वी आर नॉट गोइंग टू राइट कोड फॉर दैट पर्टिकुलर एल्गोरिथम, वी आर गोइंग टू यूज लाइब्रेरीज देयर. ओके. सो मैं बड़ा कर्सरी रूप से समझाऊंगा कि काम कैसे होता है और उसका कोड कैसे लिखते हैं. उसके बाद आप लोग कोडिंग पर आ जाइएगा. ठीक है. Should we stop? It has been an hour, or should I continue? हमें क्या फर्क पड़ता है, आप जो करें. हम बैठे हैं, हम यही बैठे हैं, कहीं नहीं जा रहे. Take a break. Let's take a break. 15 मिनट के आसपास लेते हैं एंड देन वी विल कंटिन्यू. ओके.
And so quick. Level, huh? You see, I have given the link at the bottom. Okay. Tomorrow, actually, Monday route. Not here. Tomorrow there will be no. But tomorrow I'll. Hmm? हाँ? ये तो नया सॉफ्टवेयर है.
This is funny. एक मिनट रुकिएगा भैया. You know how we were worried about putting any kind of state name. मेरी यूनिवर्सिटी का जो एडमिशन ये था पहले बहुत टाइम तक, you know कैसे फॉर्म भरना है, जो गाइड बुक था. It was actually made with Angela Merkel. Technically, the chancellor of the country is applying. That was one name we all thought, take it out. No, I don't even worry. Good. Welcome back, guys. So now we will see that our task is to classify. We'll first learn how can we classify between given objects, okay, or between given a series of things. So one of the decent algorithm is random forest, and random forest believes in the approach that rather than one straightforward system applying, it's not a neural network as such yet. If you're going to watch a match today, there are 12 of us, okay, or 11 of us. Each 11 of us will have a different opinion on the performance of a player. Right? So rather किसी एक का opinion लेने की जगह हम सारे 11 लोगों का opinion लें और उसके बाद majority pooling कर लें, और that will tell us. And I'm assuming कि all 11 of us are hockey experts. ठीक है? तो अगर 11 hockey experts कह रहे हैं कि ये player, और 11 में से 6 कह रहे हैं, तो there's a majority evidence कि that person is the good one. So that is the strategy used by random forest rather than having one approach. Okay, second year students, आप लोग tree पढ़े हैं अभी तक? Tree. So you have done binary search tree and decision tree in your thing. Oh good, then I don't have to teach decision tree. Okay. So the idea here is this, that you make classification trees, but rather than making one classification tree, you make many different classification tree, each randomly dealing with a different subset of data. Okay, सारे data so ये ना करें. Or each tree B is also looking at a different feature, and you use a bootstrap sample. So there are many ways of making multiple trees. One way says कि एक tree बनाए and the next tree influences the tree which have been made earlier. So in random forest, the idea is each tree is kinda randomly independent and not correlated with one another. Okay? And then to each tree you give a different sample on which it is going to learn its ability to classify. At the end of the day, you take all the classifications. Say in our case, 1/3 of the training data was not even used for making the trees, but was used for out of bag error estimation and importance measurement, कि ये feature important है या नहीं है. Right? So by an iterative process, random forest makes the various different classifiers. Now the reason why I'm taking a pause is I'm thinking how deep we go in. We have got an hour to cover 3 different ways. You know what? Let's go quickly. So random forest can be used for classification. You will have these slides so you can go back and visit, but can also be used for regression, for identifying. It's not a very good regression, it's not a bad regression either. तो अगर हमें exact yield predict करना हो तो भी हम random forest कर सकते हैं. But जब आप classify कर रहे हैं, जब आप कह रहे हैं कि individual tree का हर का result क्या है, and let's take the majority. जब आप regress कर रहे हैं तो हर tree एक एक result देगा, तो now majority तो ले नहीं सकते. So we generally go for an average of all the polls. सारे trees का अगर हम average ले लें, जैसे हम लोग अगर individual rating करने लगे players को, तो we take the average rating of all the players and we have got a thing. Now there are some hyperparameters. आपने tree अगर आप लोग already deal कर चुके हैं, तो you can look at how deep the tree is. That could be a parameter in each individual element, how deep the tree. How many trees do we form? Depending upon the data, that will determine. So these are the parameters which you can tune, and we will see that shortly. और उसके बाद हम bootstrapping aggregate करते हैं, right? So data points में हमने n independent subtrees बनाए, and each decision tree को we will train on each subset. Each decision tree will be trained on its own subset of data, hoping that between different decision trees we have got smaller variance. So each tree works independently, and because it's independent, सबका काम एक साथ होगा तो the polling will be fine. The other way to classify numbers is to look at k nearest neighbors, and this is a fairly old classification routine. बहुत अच्छी नहीं काम करते, but it's an easy routine to explain. But generally here, when application you take k to be typically the square root of the number of observations, और उतने आप ये देखिए कि हमारे उतने नेबर अगर हमारे पास हैं तो हमारा एक ग्रुप फॉर्म कर रहा है. तो you just look at how many people are near you, and that will determine कि आप किस ग्रुप में establish कर रहे हो. तो जैसे अगर हम इस रूम को k nearest neighbor में क्लासीफाई करें तो I become as individual को मेरे पास कुछ नहीं है, these 4 become part of one group, those 5 or 6 become part of one group. So you just look at आपके पास कितने लोग हैं. Let's come back to it in a minute. Okay, let's come back to boosted general linearized model in a minute. Let's see हम implement कैसे करेंगे. So why don't we open our Python now and go through an implementation strategy. Okay. अभी हम yield data पर काम नहीं करेंगे, yield data पर शाम को करेंगे. Let's just try to go through individual stuff. So as usual, पहला काम क्या करेंगे? We'll import various libraries. तो 3 लाइब्रेरी जो हमें चाहिए होंगे to work with data are pandas and numpy, और pyplot यूज करेंगे for any plotting अगर जरूरत हो. तो let's import that thing. First step is almost always easy. You read the file. I'm kind of hoping the data is in a CSV format, so data ये करेंगे, and किस फाइल को पढ़ा जाए. कल हम लोग का कोई डेटा मल्टी कॉलम डेटा नहीं था ना, कल जब हम लोग हैंडल कर रहे थे, we only had single column data. Okay, so go back to that web page. And let's download a data set. So you are there. Let's see किस डेटा के साथ प्ले किया जाए शुरू में. You know what? Why don't we download the to do something went wrong. तो अगर आप sugar directory में हैं, then what you will find, there will be a data set called uci-ccom.csv. Okay, so download the data and look at the data. How does it look like? Do you want me to read or उसको वापस स्क्रीन पे डाल दूं मैं? I will do that. I think that's the link. Do you get this file uci minus ccom.csv? Good. देखिए ये data set है कैसा. So what does it have? Can somebody tell me? Now this is not a data set on which we did the work, क्योंकि हम शाम को बताएंगे how complex our data set. I've taken a much simpler, still a yield prediction data set for semiconductor manufacturing. So if you look at the CSV file, what do you see there? कितने कॉलम्स कितने रोज का डेटा है? या आप किसी को नहीं मिल रहा है क्या ये? How many columns do you have? How many rows do you have? 1560, right? 1560 rows. How many columns do you have? You should have 590 columns. Okay? So we are saying that we have got 589 parameters. अगर आप लोग एक्सेल में खोल रहे हैं then it lists columns as A, B, C. मैं Mac use कर रहा हूँ numbers this way I can say it quickly. So we have got 589 different data coming from different things. Just have a look at this data. There are some data which is missing. Some data is in a different number system. There's zeros. Some of them have got many different numbers of fractions. Okay, there are tons of zeros. There are numbers of different type, and it's a huge data set. If you go back to the last column of your data set, that's a pass fail kind number. So automatically it has already done to you, it's already giving you -1 for 1 for pass, -1 for fail, and so on and so forth. Okay, good. So ये हमारा डेटा सेट है, हम इसको यूज करेंगे. मैं पहले सोच रहा था कि to go with some other data set to train you, but let's go straight into a semiconductor data set. Okay. तो इसको पढ़ा जाए. The thing which is interesting, remember, is इसका पहला column is not an index. What is the first column? It's a timestamp. So we have to tell DF, और जब खासकर जब हम Panda read CSV करेंगे, we have to tell that it is a timestamp data. तो अगर आप लोग पिछला कोड लिखे थे, अगर आपको याद हो, हमारे पास एक टाइम पार्सर मेथड था. So we have to ensure we give the time parser method to Panda read CSV to ensure कि, and we have to tell कि index पहला column है, and there could be time like data here. Okay, so let's read that file. So parse dates, parse underscore dates should be true, and index column should be, which is the index column? Do we have a 0 column, or is the column called time here? The index is being called time. If you look at the name of the column, it's called time. So index column should become time. Don't forget the single quotes there. So file in double quotes, time in single quotes. Okay. So that's the first thing. We have read the file. All of you have read the file in your Python script. आप लोग क्या use कर रहे हैं? Are you using Colab or you're using on your sim? सबके सवाल सी हो गया, right? You don't want to be a reason for अगर कोई package missing हो तो install करने का मेहनत ना करना पड़े. That's the only reason you're using Colab, right? आप सबके पास मैंने Anaconda शुरू में करवाया था कि have a Python running on your own machine. ठीक है. You can do a df.head just to check that file has been read properly. So run a df.head and see if मिला है सब कुछ. Now generally, now this is an optional statement right now. For this code we will not do it, but generally जब आप कोई भी code लिखिएगा so it might not be a bad idea to remove the not available, the NA columns. You can just do drop NA or remove a particular column. अगर a few columns आपको ज़रूरत नहीं है तो मत है. मैं इसमें आपको drop NA नहीं करने को कहूँगा because virtually every row and column has some data missing. So let's not do that. Good. Everyone is with me? कि कोई पीछे पड़ा है? पीछे पड़े हो तो अभी रोको मुझे, मैं फिर से explain करूँगा. I will come to your machine and explain. Okay? Should I come to you or you are okay? I will come to you. Because फिर मुझे वापस आके आपको करना होगा, which is csv. फाइल रखे हो कहाँ पर? What's on your machine? Okay? Good. So everyone has been able to read the file? That side. आप लोग worried दिख रहे हैं. आप लोग तो पढ़ ही लिए होंगे, आपके पीछे वाले बच्चे. हो गया? नहीं हुआ? तो हाथ क्यों नहीं उठाया? 2 मिनट. हमारे यहाँ 2 मिनट्स में तो सब कुछ हो जाता है. I should still have a look.
Note this.
Oopsie, sorry. So we'll give another minute to that group and then go on. So हमारा data size छोटा है पर उतना भी छोटा नहीं है, right? We have 1500 into 600 columns. We're talking about a decent number of data points here. You know what? Type कर ही देता हूँ. So guys, something like this, those who are missing, ये वाला step सब लोग कर लिए हैं? Good. And this would be depending upon कहाँ आपका file saved है. Okay, which location you have saved, you might have to give the path location here. But और क्या डालेंगे इसमें? Parse underscore dates is equal to true. Index column is single quotes कहाँ है इस कंप्यूटर पे? that should do. Good. इस स्टेप को अभी नहीं करते हैं, बट यू कैन डू इट इन ए नॉर्मल सीक्वेंस, क्योंकि हमारा डेटा बड़ा ही डॉची है. तो लेट्स गो. मैं पहला आपको बताऊंगा, बट यू विल ऑल्सो बी डूइंग डिसीजन ट्री क्लासीफायर एज वेल एज हाई ग्रेडियंट बूस्टिंग क्लासीफायर, और ऑलमोस्ट सब में सीक्वेंस ऑफ स्टेप यही होगा. ओके. नाउ जनरली दिस इज अनदर रूल ऑफ थम्ब. इस वाले में हमारा एडवांटेज ये है कि पास और फेल कॉलम इज ऑलरेडी न्यूमेरिक, राइट. इट इज हैविंग 1 and -1, तो विच इज फाइन फॉर अस. एक्चुअली नो व्हाट, लेट्स चेक कितने हैं पास और फेल कॉलम वाले. सो लेट्स डू sizes. So हमें क्या करना है? We want to check the column which has got pass fail. So we are now checking the column which has pass fail has a value underscore counts. So it is equal to 1. अगर आप अलग लाइन में चला रहे हैं तो it should work. If you want to print this, this should be. So can each one of you tell me how many pass fails you have in your last column? So how many ones and how many minus ones do you have there? Because that will tell us how classified the data is. Give me a number. So minus 1 is 1463. We don't know if minus 1 mean fail here. Okay, it could have meant pass, but that's least of our concern right now. So all you want to see is we have two types of classification result here. दो ही हैं, right? So there is a minus 1 type and there is 1 type. Minus 1 के data set 1463 है और 1 के 104 हैं. So it's very heavily tilted towards minus 1. So it's a good data set which it's not equally divided. It's not a pure thing. Okay. Everyone is with me? Good. सर जी आगे वरना मतलब मेरा टाइम हो रहा है, right? Let's do one more slide and then we will come back and finish it after the lunch अगर जरूरत पड़ी. So if my last column was not numeric, this is the time to assign a numeric value to it. Okay. Now, other things are not numeric, we may also have to assign. It's a good idea to assign numeric values to this thing. नहीं है तो फिर देखा जाएगा. Now we need to tell to Python कि कौन सा कॉलम हमारा आउटपुट कॉलम है और कौन से कॉलम इनपुट कॉलम्स हैं. ये तो बताना पड़ेगा ना. अभी तो डेटा प्लेन है. हमारे साथ ब्यूटी ये है कि हमारा लास्ट कॉलम आउटपुट कॉलम है. तो व्हाई डोंट वी टेल इट that give the column name and these values and we make it into a y variable. So एक नया variable create कर रहे हैं with just we are having the last column. Got it? Without error? Good. So what do we do next? So y might be an object at this time. It may not be a bad idea to change this type to become a normal integer. And that which we'll do with this line, y is equal to s type as integer. What's the name of my column? Fail pass or pass fail? So pass fail. Now, everything which is not the last column is my training data. हमारा database बढ़िया है. Last column को अगर हटा दें तो everything else is my input data. Let's do that. Let's make x my input data as just drop that particular column and leave everything, and that becomes, so हमारे पास x और y ready हो गया. Now generally जब भी आप कोई AI का मॉडल लिखेंगे तो most of the time you will spend in data pre-processing, actual and of course training time on this thing, but coding में data pre-processing में आपका जितना ज़्यादा time जाएगा उतना अच्छा है. Okay? Now हमारे पास एक बड़ा data set है और हम इसको we are going to learn how to classify it. How do we check कि हमारा classification सही है कि नहीं है? So one thing we could do, कि उसी data set को हम दो भाग में divide कर दें. एक भाग training के लिए use करेंगे और जो second half है that we will use for classification. We can do it manually. Manually we can say row 1 से 1400 row तक को आप use it for training and use the rest of it for testing, or the sklearn, the scikit-learn module. This is what we'll be using quite extensively, this library. It gives us a library already to split the data between testing and splitting. Somebody is looking at that computer. क्या चल रहा है? You're okay? Not okay? We are okay, good. So let's do it automatically now. So now we import the train test split package from sklearn.model_selection library. And all we do is we run a very simple command. We find a training x data, we find testing x data, training y data. Let's make everything capital just for fun. And we create a y test data, which then takes the input of x and y. And here are two parameters worth checking. One is, what percentage of my data should be used for testing? Here I have given 40%. Let's reduce it to 20%. This is the number we'll play with later. कि कितना set of data is enough for us to train a good classifier. Now this partitioning is generally random. Okay. What we were going to put here, random state is equal to 20, to ensure every time I run this model, it partitions it. So give any number to random state, but keep it same for every time you run your code. And जो घबरा रहे हैं, there's only one more slide and we are done with it. So is everyone with me? Have you been able to partition your data set into a training and testing data set? Should I move on? Good. If I come back and I see somebody has not done it, this is the time you will see my Rudra Roop. So you have to, if I have to slow down now. Okay, so let's go to the next bit. So now we have got a data set, we have divided it into training and testing. Now all we need is to do is to run our classifier. So once again from sklearn, we import random forest classifier. And once we have imported it, then life is very easy. All we do is we create a model, or we create whatever you call it, of random forest classifier. We give some hyperparameters. To start with, let's give a number of estimators to be 10. So it forms 10 decision trees. You can increase the number of decision trees later. And then very simple, you do model.fit, which runs the training data, and then you do model. So this model.fit will give you create the model which does the random forest fitting between the two sides of training data. We have used capital Y, so let's keep capital Y. And then we take the testing data and do a prediction based on the same model which we have fitted. So, and if you're all working fine, by now you should have got your random forest classifier trained and fitted. Any errors anyone is facing, or it's all working fine? And we are done. As far as prediction is done, we are done. We have just need to check how good our prediction is. Right? So that's the only step we will do. So pretty much most of your things will follow the similar strategy. Create the data, import the library, create a model, fit the model, and then predict based on the model. So 4-5 lines of code. Of course, if you are very interested, you can go and write your own code for a random classifier, a random forest classifier. That will be the fun to write, but let's not delve there today. Is everyone having problem? Good. But here you have these slides. You don't need to take a picture. The slides are online. You can download. Okay. Let me see. No. What was the output column name? क्या नाम था? Okay, let's have a look. डाल के देखने से क्यों? हाँ तो लिया नहीं तो बुलाया क्यों नहीं? वो होता है कंप्यूटर जर्नी हमको देख के काम करना शुरू करता है. Good. How are you? Oh, okay. ठीक है. This is your home Jupyter. Is your Jupyter getting overloaded क्योंकि आप memory कम हो जा रहा है आपका? Oh, okay. आप fresh लिख रहे हो. ठीक है. You can see the direct slides online. Google Drive पर जाएंगे ना? You're comfortable with videos. Okay. The modern generation comfortable with videos. आपको कैसा चल रहा है? हो गया? Fitting prediction हो गया? You didn't get any, so why don't you call me? Huh? Come on, let me see. Smile is not an answer. It's a pretty smile, but it's not an answer. So you are able to read the code. Okay, so that works fine. Good. And then you were able to get the sizes. Did it work? This did not work. Why do you have y is equal to here? So before proceeding, let's delete this. Right, it's taking space. So this did not work. Actually, you know what? If that's not coming, don't print. Go straight. That will tell us whether this line was true or not. So there was something problematic. What is problematic? There's something problematic way before that. Pie plot. So don't trust कि आपका अगर this is not pie lot, this is pie plot. यहाँ पर Are you running on your machine or have you installed matplotlib here? नहीं है तो कोई बात नहीं. We're not going to plot things for the time being. Okay, let's just keep it as it is. So let's run it again. Can you show me that file, the CCAM file? What's the name of the last column? I want to check. Okay, then I'll be back in a second. होल्ड से नीचे एरर में मत जाइए. किस फर्स्ट लाइन कौन सा एरर दे रहा है? सो मॉडल डॉट आपका मॉडल नहीं काम कर रहा है क्यों भाई? व्हाट इज द एरर इट्स शोइंग? आपको नैन हटाना पड़ेगा. ओके, देन डू द प्रीवियस स्टेप व्हेन वी रिमूव द नैन. Okay, let me do one thing. Let me just go through the theory for one more slide and then I will come back, and because some of you are already at a stage where you have got it working, others are waiting. So once you have done the prediction, the next step to do is to check how good my fitting is. And there what you have to do is, you can do it manually, you can find the errors manually, but again there is a metrics package there. So import the metrics package and it can immediately check how good your accuracy score is. The final thing to do is to see, are there any particular columns which are more important for this yield prediction? And that we can check from a feature list. We can identify which of these columns are more important in telling us whether it's passed or failed. Okay. And that's it. That will be all for random forest. And those who have done random forest, I would want you to see if you can implement the decision tree classifier. One word decision tree classifier, and if you follow the exactly same step, create your model, fit your model, predict your model, and then check how good the model is. And what you need to do is then tell me, compared to your random forest, how good or bad the decision tree is. Okay, and now we'll go around checking people, those who have got it working. So are you running on Google or are you running on your own machine?
On machine.
Maybe that's where the issue lies. Can you run it on Colab? Okay, because then that also gives you code completion issues. Okay, do you have Colab access or no?
I didn't access.
Sorry?
I didn't access earlier.
Do you have a Google account?
Yes.
काफ़ी है. So search Colab. Unless आप अपना पूरा कोटा यूज़ कर गए हैं अभी तक का. And it looks very much like a Jupyter notebook. And the only reason है कि मुझे नहीं पता है आपने क्या क्या installed है. So that way I don't have to worry about your individual machine. So let's just start a new one. Yeah, that's it. And it's very much like a Jupyter notebook after that. What about you guys? Where are you stuck? So input to the table आपने कर दिया. So train test कर लिया. Which is not working. क्यों नहीं काम? Unmatched syntax. Syntax करवा रहे बाबू कहीं. Extrain. पहली बात space क्यों दे रहे हो यहाँ पर? Hold on, go back to that line. I will be able to do it. So yeah, space क्यों दे रहे हो यहाँ? This is not y space train, it's y underscore train. या फिर कुछ नाम दो, स्पेस वेरिएबल्स के नाम में नहीं रह सकता ना. Okay, that should work. हाँ, okay, gives either a single word बना दो or give a space. What about you two girls? There's an error, right? And they didn't think it worthy enough to tell it to me. You accepted the error as a way of life. No, this is an interpreter language. So that's the difference between a compiler and interpreter. Here, if the first line, one line doesn't work, how do you know the next line will work? It's not like life. ये वाला exam fail किया अगला pass कर जाएंगे. Right? So always go for the first error and fix the first error before going down. Okay, so let's look at what's your error here. Data output values. Why data? ये line output है क्या आपका? So this is what. So here we counted the number of pass and fail. Okay. Now we are asking which column of our data contains the output. Now you are saying the output, the column labeled output is the one which is containing my classifiers. Do you have a column labeled output in your data? What's the column? What's the name of the column? So shouldn't we? because that's where it can't find that column. There is no column called output. So if we do pass/fail, that should work. What have I done? Okay, so that has worked now, right? Next is this line, labels. Don't think it's plural, but just check. Okay, that's what it's saying. It cannot find labels. So don't be in a hurry to write the whole thing. If one line does not work, the other line will not work. So label, what's the spelling? It is labels. Labels, spelling was wrong. Labels. Okay, now the next line has got its own set of problem, but go line by line. Don't write the whole code and hope. Unfortunately, computers are not intelligent enough to look at your hope. Okay, good. What about you, girl? What's the error? Could not convert string to float. Go up, go up, go up, 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 up. The error is in line number 3. So there are 2 types of error in a computer code, at least 2 types of error. One is what we call as syntax error, which your syntax highlighter tells you. Other is called a functional error. So computer program works fine, it just doesn't do what you wanted it to do. Okay? So line number 3 worked fine. It read the database. The problem is, it read the database as it is. The first line of my database, look at your data set. Can you open it in Excel or any other? What's the first column? No, first column. That's not the first column. That's not the first column. That's the column VH. Go to the column A. First column. नहीं नहीं ये उसी में जाइए. Go in Excel. Go in Excel. Is this the first column? So Excel का column starts with column number A. It's a huge data. दिखेगा नहीं. पहला column क्या है? Make it bigger because it's right now it's showing. Make the first column bigger. क्या है? It's a timestamp, right? It's not a number. So what when your CVS read has basically read it as a string. So you need to do here, you need to tell it that yes, there are dates in my parts. Dates is equal to true. Okay, check as if dates are, and now hope I've written it properly. Now it is telling the first column is a date and time. Got it? But it's not thinking that's the index. It's still creating an index 0, 1, 2, 3, 4. We have to tell it my index is the time one. Okay? So here we will tell index is equal to time. Daisy, क्या कर दिया? What mistake have I done? At this point my brain is dying. index column, sorry. Index column is equal to, see, now it says that's has become my index. So don't use that data for trading. Time data we are not going to use for trading, right? There's no advantage using it. Good. आपका क्या हो रहा है? हो रहा है, कहाँ अटके हैं. तो अटकने पर आई नो यहाँ पर प्रोफेसर से काम नहीं कराया जाता है, बट हम कह रहे हैं आप लोग मुझसे बोलिए, देन आई कैन हेल्प यू. सीधे अगर मैं लेक्चर दे के वापस चला जाऊँ और आप लोग कुछ ना सीखें तो फिर लेक्चर देने का फ़ायदा क्या हुआ? और फिर मैं रात भर जग के कोड बनाने का फ़ायदा क्या हुआ? टू चेक दैट द थिंग वर्क्स. और आई वुड हैव जस्ट गिवन यू कि इस तरह से रैंडम फॉरेस्ट काम करता है, आप जाके ट्राई कीजिए. सो क्या एरर दे रहा है? With n samples is equal to 0, test size adjust any of the aforementioned parameter. Okay, let us see. इसके पहले हमने कुछ गड़बड़ किया है. हाँ, हमने गड़बड़ किया है. The error lies in line number 5, and you have also done drop NA as well. No, yeah, okay, there. So the problem here is this. This data set has got not a single row or a column यहाँ पर कुछ data missing नहीं है. So if you do here, after df drop head, there is no data here. There is just the column. No, so no, so ये तो random column तो बाद में drop कर रहे हैं हम लोग. यहाँ पर you did df dot drop na. You basically said, so drop na what it does, अगर कहीं भी एक data missing है तो it removes that row and that column, right? So there is not available data. So essentially we have got every row and column has got one data missing. So what it did, it removed everything. What are you left with? Just the top line. Okay, so पहली गलती वो की आपने. चलिए हम let's not drop anything. Let's delete the whole dropping business, and we might have to go to let's run. नहीं, अब जाके run हुआ. Now you can see I have the whole data. I still have a problem. Python ने assume नहीं nan तो बाद में देखेंगे. Python assumed कि this is also data, but ये तो आपका index है ना. This is the index. It has created its own index 0 1 2 3 4. तो हम लोग जब यहाँ पढ़ रहे हैं तभी हमें बोलना पड़ेगा इसको index underscore column is equal to time. So जिस कॉलम के ऊपर में टाइम लिखा हुआ है that's my index. तो अगर हम वो करें तो it says that has become my index. Now I might be lucky. Why is giving df 11? 11 to 11th column इसका हो जाएगा ना. Which column has got my output? So let's call it the pass fail column. That is my output data. Okay, ठीक, carry on. जनता ब्रेक लेते हैं. 12:30 हो गया. I'll just come and have a look at that side, and then we will take a lunch break and we'll come back after lunch break to finish it. आप लोग क्या हो रहा है? अटके हुए हैं या फिर गाड़ी चल गई है? What's going on? क्या हो रहा है भाई? लोगों को तो आना ही चाहिए. This is too easy. But random forest का result है, right? Plot कर दीजिए. Because plot will tell you कहाँ पर where it's not predicting. Dude, decision tree. I thought by now you should have done decision tree and compared it to it. नहीं, same code लिखिए ना. This in sklearn there is a decision tree as well. Don't write a code for decision tree. Okay? यही 4 line जो आपने लिखा है random forest classifier, replace the word random forest classifier with decision tree classifier. हाँ. Okay? Good. Let's take a break, guys, and then we meet after lunch. Okay? What time are we meeting? 3 o'clock again today. Okay? Enjoy the lunch. Bye. Right. Good afternoon, and we are back. So one of the things which we said we will do right in the beginning, and I know we'll get back to our random forest soon, was that we will try to collect all your financial information and see if it makes sense. Unfortunately, we only have 18 people, so most probably none of the classifiers will work. But hey, we can always add some artificial data after that. So let's start by asking the question, what information should we collect and how we should collect? So considering there's a short room, we could do a questionnaire and all of you can fill a form, but that's not necessarily the best way of digitizing. So I started doing a Google form during the lunch break, but I thought rather than finishing it myself, why don't we do it together and see if you think any other information should be added, because we have a hypothesis that our expenditure is dependent to our gender, and we are going to either prove it wrong or prove it right. Okay, so I thought a good thing to start would be some sort of identifier. No one should enter their name. Agreed? So some sort of identifier. Gender, actually we can make gender a binary question, can't we? Actually we can't make a gender a binary question. Sorry. So let's make it a multiple choice question. So what are the choices we can? What's the legal requirement in India right now for gender? Does anyone know? What's the legal requirement when collecting gender data, and what kind of gender options we have to provide? And actually, now that you have said that, I need to check. I thought third gender was to be included in all the forms. The transgendered community. Okay. Right. So let's make this form a multiple choice. So it becomes. So we will put male, female, others. Right. What other would we need? So rather than asking people date of birth, that will be too much. I guess year of birth is a decent discriminator, right? Because I thought maybe as you grow old, your expenditure either tapers or follows a different path. Things which I thought could add more data to us could be things like where do they live. If you live in a village, I guess your expenditure will be different. So rural, small town, medium-sized town, large city, and other. Is there any other choice to be given there? And then of course this has to affect how you are doing it, right? With parents, in hostel, shared flat, or on your own. Will that be a concern? And then I thought this one, how frequently do you eat outside? Should not be a multiple choice question, it should be a short answer, right? Or should it be a multiple choice question? Why? Yeah, once a week. You're right. But it could be once a day as well, or twice a day for some people. Eat outside in a week. Let's give it in a week option. Now, to make life tricky for data analysis, this is what I want to do, to see if you can manipulate this data in Python. So we have got 12-month data, okay? If I go and fill a form for each month, I will have to create 12 questions, and I got tired of doing this. So I thought, let's ask people to enter data as in, comma separated, simple, right? So January, February, you just put 1000, comma 1000, and for 12 months you should have 12 data samples. And if people also have their 23 data, then they give their 23 data as well. In place of name, put a random identifier which you think you will be able to identify yourself by, but nobody else will be, right? So I could go with my childhood name, Bhushan, which you guys don't know, or no, the cool boy from the hills, if you can think that. Anyway, I'm sure you know how to create unique identifier. Is there any other information which can tell us something about our expenditure? Or you think it will be good? It's an open discussion. But do you give college fee per month? But per 6 months, so it's not a monthly expenditure. Mess fee is a monthly expenditure, and does that vary dramatically between institutions? Does it? But the thing is, if you take out mess fee from your instrumentation, you don't have much costs. And the other thing is that 2 people or 3 people studying in the same place will have the same mess fee or similar-ish mess fee. Let's leave that question. Well, the reason why I'm thinking is, of course, then you can ask people who eat non-vegetarian food will have higher expenditure than people who eat vegetarian food. And I don't want my data set to become too complex. But because if you start looking in that, then there are no binary divisions here. Anything else which is easy to explain about people? Do we have enough data sample on that value? The thing which would be worth checking is things like people who have long hair, what's their cost of shampoo compared to people who have hair like me? Right? Do we have enough differentiator? Maybe not. Okay, so let's submit this form. So on the shared drive there, all of you guys have access to this form. Okay, so you can fill, that's the final form. You can fill the form, it will automatically create an Excel sheet. And then we will try to ask the inverse question, not the direct question first. So direct question first was girls spend more money. Okay, I don't believe in that. Let's do the inverse question. Looking at the expenditure, can you tell the gender? So you train a software saying something. So how many we have got? About 4, 5, 9, 13, 14, 15, 16. I won't add mine because my expenditure will be in euros, so that will become quite low. We have about 16 data points here. So 16 into 12 becomes 250 odd data points, right? So we have decent number of data points. So what we do is we train for, say, 14 into 12, and then ask it to then put 2 of them as testing samples and see if it can predict whether you are a man or a woman based on your expenditure. Okay? So, but first that ensures that all of you will enter a figure, a truthful figure. So we'll run for next 5 minutes. You can go on your computer and give us this data, and we'll see how quickly the data comes. Is everyone clear? सबकी समझ में आ रहा है क्या करना है? And don't worry, आपके माता पिता को ये डेटा नहीं जाएगा. एक्चुअली मैं सारे क्वेश्चन को इलेक्टिव बना देता हूँ, इसलिए सो दैट अगर कोई नहीं कुछ इन्फॉर्मेशन डालना चाहे तो वो भी होगा, सो दैट वी विल गेट सम नॉट डेटा. आपको अगर इफ यू ओपन दैट लिंक यू शुड गेट दैट क्वेश्चनएयर, राइट? क्वेश्चनएयर मिल रहा है, इसका नाम जस्ट डेटा कलेक्शन फॉर्म्स है उस लिंक पर. एंड बगल वाले का डेटा नहीं देखना है, या फिर बगल वाली का लिंक मिला आपको? आप लोग को लिंक है यहाँ पर? गुड. यू गाइज हैव द लिंक? I must confess, जब मैंने कोर्स प्लानिंग किया था, this was nowhere in my plan of things. I will be asking this silly question, but are you kidding me? So one thing before you do a study, it's always a good idea to look कि किसी और गधे ने study किया है क्या. The first part of doing research. Somebody asked me a question about how to get in research. That's how you start by doing. And this is what annoys you the most. I've got a bright idea, and look at the first search result. Average monthly expenditure of a student by gender. Let's see, is this a meaningful data or is it just a... खुल जाओ भाई. Interesting. So let me see how many of you have. अभी तक एक भी रिस्पॉन्स नहीं. What happened? Sorry? एक मिनट रुको. So you're not getting a submit option. Just give me a second. Just give me. I know. Wait, हमने publish तो किया ही है इसको. Okay. I got it. Just a second. Forms. forms.google.com. So this. I have published it. Now I've got 2 responses now. So somebody can submit, right? And for heaven's sake, Pratyush, नाम बदलने को कहा था भाई, एनोनिमाइज्ड डेटा कलेक्ट करने को कहा था। सर हम लोग हिंदुस्तानी आधार कार्ड तो सबको देते चलते हैं। Can you guys are getting link form or नहीं? By default देवा। I mean ideally, but देखते हैं कैसा। I can. Jeet as a man and Elsa as a woman. Somebody has seen Frozen movies quite a lot. Good. So while I do the analysis, let's go back to our. So हम लोग शुरू कर रहे थे just before the lunch break. A number of you were looking at. Just a second. Can I somehow share my screen? Because मैं इस कंप्यूटर पर लॉगिन नहीं करना चाहता, पब्लिक मशीन है ना। I've got a just वो अगर लगा सके, even if it's not seen to have shown to everyone else. To everyone else, we can leave it here. Where is your projector connected? So we just connect the projector. Or will it be too messy? It's already too messy. Okay, leave it. Leave it. Let's. Leave it. Let's see if this. What I can certainly do. Sorry, मेरा network connectivity थोड़ा आज fishy हो रहा है. Save. Download. Okay, we have got the data now, all of it. And this is classically going to tell you the first one. So अभी तक जो भी data samples आप लोग handle किए हैं, they all have been nice data. Properly structured data, nicely entered. हर column में एक data था. And this short exercise immediately tells us the problem faced with people who collect data. We had, and the moment we gave free flow entry to people, they took their own liberty in ways they enter. And there's nothing wrong or right about it. This is what happens whenever you collect data. So we had people who had entered just pure numbers. We had people who entered 1000 and put a comma there, and then there's another comma, so it's going to become very difficult for us. Which comma means what? Okay. थोड़ी difficulty होगी हमें. Because we were thinking comma is just separating by month, but now we have comma in 1000 as well. There were people who also just entered their normal expenditure and rest all they said fine baki kharcha aage hai. Okay. So and then there were people who entered zero information in some months. So we already have diversity in data. So our first task will be to clean this data. Before I give it to any operating system, I need to clean this thing. So things which I need to clean are also here. Look at how frequently do we eat outside. We have got numbers. We have got alphanumeric characters. We have got other things. So either I run another chat GPT kind thing and ask it to translate on an AI intruder, or I run if it was a very long list, my life would have been very tricky. And this was precisely the reason I made people to enter this information as a chart. And there are people who have somehow managed to eat outside and still have 000 rupees expenditure. पहले ये बताओ कि कौन support कर रहा है यार, I want to be with that person. But that's perfectly fine. And this is precisely the reason I asked you guys to not enter your name, so that I can make fun of your entry without you knowing what's going on. And there's a problem all data analysis suffers. And now assume this was a sensor, right? हम sensor से data collect करें. That just means the sensor went wobbly-dobbly at that time. Right? It started entering proper information, and after a while it said, you know what, things are not working. Okay. So other thing which you might have to do, you might have to remove, there are a lot of people with zero. What's going on? कुछ गड़बड़ लग रहा है ना? Or do you think it's 5,000? But then there are loads of zeros. This does not make sense. कुछ सही नहीं लग रहा है. Let me have a look. This might also be when you translate data from responses to Google Sheets, but I can see actual information of everyone. So the first person who is problematic is number 3, who is John Carter. And why am I not surprised John Carter is problematic? No, okay. That makes sense. Can I make it bigger? So it's not 00, it's presumably 12,000, and for some reason that number 12 is not visible. Okay? So it's not 0 rupees, it's 12,000. 12,000 rupees mein aap 2 baar bahar kha rahe ho. You should be eating more, right, for 12,000 rupees. Anyway, so I will do the data cleaning and pruning while in the background. Let's see where we were when it comes to. So did everyone reach till this stage? Were you able to do the model prediction? Okay. So the next stage would have been to check how good our model is. And this is to learn metrics from sklearn, import sklearn, and then just look at the accuracy score between y test and y predicted. And this should have been capital because I am using caps. The other thing which you could do is to look at feature list, look at which columns have got predominant features, and then just list it according to an ascending order. Okay, so you can see which are the top 5 columns which are hurting, which are causing the most important thing in this. So can people tell me what was their accuracy when you did your print accuracy of something? What was their accuracy? .90 for decision tree, random forest 9.4. Okay. Any other number? First and foremost, is everyone's random forest is running? It's running? Not running? Call me. I'll come and fix it. Because now what we will do is we'll start tuning the parameters of random forest. अभी तक हमने ये नहीं किया कि हम कुछ बदलेंगे तो क्या होगा. Okay, so let me have quick look at these people. It will only take a minute to fix.
So the value of x and y is already given.
Hmm?
The values of x and y.
Can I? One thing I will advise, just to be on the safe side, if you can go on Colab.
So I'm going to
Do you have a Google account?
yes.
That's enough. Do you know how to use internet?
Yes.
That's enough. मैं इसलिए कर रहा हूँ ना कि अगर आपके पास जो सारे मॉड्यूल्स इंस्टॉल नहीं है तो उसका हमको ड्रॉबैक नहीं झेलेंगे हम. गूगल लॉग्ड इन है आप? तो and just copy and paste. It looks like a Jupyter notebook. कुछ ऐसे ही लॉगिन हो जाएगा. विल स्टार्ट के. आपका क्या चल रहा है? किसमें? Yes, the value is trying to be set on the copy of slice from a data frame. Let's see. उसके पहले भी आपका एरर है. प्रिंट स्मॉल भी जाएगा. Okay. Try again. ठीक है. गुड. नेक्स्ट को ट्राई. अच्छा, ड्रॉप इन मत कीजिए अभी. इसलिए ड्रॉप इन कीजिए इस डेटा में देयर आर ऑलवेज अ रो और कॉलम विच हैज नो वैल्यू. सो ड्रॉप इन गोज टू डिलीट एवरीथिंग. ओके. और पास फेल को भी ड्रॉप क्यों करें? उसी में तो हमारा आउटपुट था. ओके. इसीलिए गलत हो रहा है. ठीक है. सो जस्ट डू वन थिंग. कॉपी द होल टेक्स्ट एट वन गो. हाँ, नहीं, द होल थिंग एट वन गो. जहाँ नहीं करेगा विल सी. व्हाट अबाउट यू गाइस? आपका चल रहा है?
Sir, I'll put everything in one side.
हाँ, उसके बाद में एरर होगा तो आके देखेंगे. मैं हूँ ना. क्या एरर हो रहा है? सो आप भी लोकल होस्ट पर हो ना. सो ये मैं अक्सर देख रहा हूँ, खासकर जो अपने कंप्यूटर पर रन कर रहे हैं उनका रैंडम फॉरेस्ट इज अनेबल टू रन बिकॉज ऑफ दीज नैन्स. दैट्स व्हाई आई एम एडवाइजिंग पीपल टू गो ऑन कोलैब. कैन यू गो ऑन कोलैब? व्हाट अबाउट यू? यू आर कॉपिंग ऑन कोलैब. गुड. What's happening there, guys? So it seems people are running on their own computer are getting nan errors. क्या? Got it? सरदार जी? नहीं? आप विशाल हो भाई, पहले लाओ. What about you guys? Got it? क्या एरर है मैं देख सकता हूँ quickly? Start coding with AI. अच्छा, sorry. Is that the first error कि उसके पहले भी कोई एरर है? हम अक्सर करते नहीं, इन सब रिजल्ट्स को हम हटा देते हैं बिकॉज इट मेक्स कोडिंग लुक्स वेरी डिफिकल्ट टू सी कहाँ से एरर हुआ है. सो जो प्रिंट आपने लगाए हैं, प्रिंट प्रेडिक्ट, सो प्रेडिक्शन तो हो ही रहा है आपका. इट इज प्रेडिक्टिंग समथिंग. इज इट द लास्ट लाइन ऑफ योर कोड? एक्यूरेसी, इसने एक्यूरेसी प्रेडिक्ट किया ही. फीचर में आपको डिफिकल्टी हो रही है ना अभी. फीचर लिस्ट एक्स. एक्स क्या है? आपका स्मॉल एक्स से नाम दिया है आपने? नहीं, देयर इज नो वेरिएबल कॉल्ड एक्स. हमारे पास एक्स का वेरिएबल कहाँ है? हाँ, राइट. Oh, there was an X earlier. No, this is feature importance is नहीं. What is there? So X dot columns. आपका variable X है? Okay. Feature underscore ये variable है. PD series model feature dot importances. Index feature. किसमें? Okay. Index. Okay. Y prediction model predict. आपने सही कोड लगाया है. प्रिडिक्ट तो नहीं कहा होगा मैंने. गुड गुड. आपकी एक एक्यूरेसी आ गई. क्या हुआ भाई?
Sir, should I import the folder again?
नहीं. अच्छा, डेटा अपलोड करना होगा ना ऊपर में. ओके.
It's showing error that
Because it can't see this file. So all those who worked on Colab, were you able to take the file from your computer, or did you uploaded the file on Colab as well? Upload करें. Can you do that for here? आपका हो गया है ना? Can you help him while I? Okay, while we start. So you know that CCAM file, usccom.csv file. You need to just upload it and put it on a disk there. Okay. Good. So what were the parameters we played with in this code earlier? हमने पहला काम ये किया कि we divided the data set into training data set and testing data set. And in this line we basically said 20% of the data should be testing data. So 80% of the data was used for training, 20% for testing. Let's change that number and see what happens. So I'll leave the freedom to you. Choose any number from 0.01 to 0.5, so half of the and then see what happens to accuracy of your random forest. And I'm not giving you a number, I want all of you, so that when you are entering by yourself, you'll be entering a different number, right? Just test data is equal to 0.2, it should go from 0.05 to 0.5, pick a number. Okay, have you done that? What about you girls? Working? Okay, let's have a look. Which line is there? The strip. Why are you stripping the column by? I didn't ask you to do that. Where? Okay, wait. Go back to code. I will help you. So first thing first, you printed the DF columns. Don't strip them. So y is not df.time. Y is the one which is telling when the output is. So किस column में output है? What is the title of the last column? Pass and fail. So we'll call it pass fail. Right? X is every column except that column.
Okay, how do you write?
You just write drop this column.
Drop last column.
No, we are saying drop the column जिसका label है pass fail. Okay, and then train करेंगे. Let's see. आप training तक ही आए हो ना अभी तक. You have only got till what happened? Pass fail does not exist in Axis. हमने कहाँ गलती की है? Which line is the error? Axis 1 था कि Axis 0 था? Okay, sorry, pass, capital F. That should do. Good. Right, let's write the next part of your code. Okay, so have you got a number? Tell us, which number did you go for and what's the accuracy you got? Oh, okay. No, hold a second. What the test size you took? You took a test size of 0.7 and you got exactly the same accuracy. ये कुछ बर्दाश्त नहीं हो रहा है. ये तो कुछ And how is it possible कि पहले you trained with 60% of data and now you are training with 30% of data? Something looks fishy, right? Should I have a look? इसीलिए फर्स्ट रो पर बैठना चाहिए. पता नहीं फर्स्ट रो के साथ क्या दुश्मनी है हर स्कूल में, right? Wait, let's have a look. So 0.4. Something looks. Mhm. 20. Can you look at the size of your X test and X train? X train. 934, but still it's too high for. Should not. So if I go for test size of 0.19. Okay, so why don't we do this thing? So assume करते हैं कि ये डेटा आपका सही है. मैंने I entered 0.9 even then. Let's plot the accuracy, the pass fail before and the pass fail predicted on the same graph. अगर दोनों exactly सही है तो पूरा straight line matching line मिलना चाहिए हमको, right? Or let's plot the pass fail. नहीं, it's 1 and -1, दो ही चीजें हैं हमारे पास, right? So let's plot them versus an index of 0 to so much and let's see how they look like. अब आप plot कर सकते हैं अभी आप लोग? Because that's a way of, because a huge amount of data set. If it is still matching, then fine. What about you guys? So there's one number. What's happening there? Did you try changing the? Change करने से क्या मिला? Hmm? Mm-hmm. Mm-hmm. Random tree, random forest, sorry, decision tree, decision. Okay, ठीक है. What about you guys? Did you try changing the? Mm-hmm. And what's your result? मैं बैठ जाऊं? That's what you want to say? कहना ही चाहते हैं कि मैं बैठा रहूं? ठीक है. What about third row? Have you got your results working? No. So don't smile. Ask me. दूसरी जगह तो हम कहते हैं काम करने के लिए पैसे मिलते हैं मुझे. क्या गड़बड़ हुआ? X test is not defined. Have you called it X test पहले? आपने इसे X trust कहा है यहाँ पर. What's your mistake?
Sir,
Hmm.
this I need to type accuracy का code ना.
Why predicted? Huh? Should I give you the code?
Sir, same thing. This
So pretty much this one.
only one line.
Oh, one line. No, import the metrics variable and then just that will do the job. Okay. Can I? Okay. What does this head mean? You need to tell me. Yes, no. So did you get an accuracy? आपने predict कर दिया है. Now write the accuracy code. That will measure कि कितना सही है. क्या हो रहा है मैडम? She has taken the ध्यान मुद्रा. अब मुझे कौन से? Come on, show me your machine. Okay, तुमने divide किया. Where is the rest of the code? लिखते हैं ना? कहाँ लिखा? Do you have my PowerPoint slides with you? Okay. Hold a second. ये है ना यहाँ पर? यहीं से कॉपी करते हैं ना? कॉपी पेस्ट कैसे भूल गई? दुनिया का सबसे आसान चीज. So extrain. So आपका फंक्शन है उधर में. So we'll copy, paste. That is your classifier. Classifier लगा दिया हमने. उसके पहले हमें लाइब्रेरी लानी थी. सबको एक साथ भी कर सकते हैं कि करने की जरूरत नहीं है. ओके तो फिटिंग तो हो गई. हम खाली एक लाइन प्रेडिक्ट करेंगे. और एक और काम करना, खास के इंटरप्रेटेड लैंग्वेज में काम कर रही हो ना जब, there is no need to write the whole thing and wait for and then test. Right? This one I'm here, I know I'll be able to fix it and then get. नींद आ रही है? You, so? Why not so? Everybody should be able to do code. Right? Coding में तो कोई no brain goes in coding. Right? That's why all of us gets job there, because we're doing df print df columns, integer, pass fail, sklearn import. Good. What's there now? Y train is not defined. What did we call these variables? We call them small y train, right? So training data is big, small, and now we have changed it to capital. So if we made it small, daisy, kya kar raha hu main? Right? So this is like calling you by a different name in a different part of. Okay, those of you who have done कितना टाइम हो रहा है? So what I will spend, I think all of you have got your random forest working now, right? So what we'll spend next 10 or 15 minutes telling you what we did the study, why it was a bit more and why we are not studying now. And then when we get time, we will go back and see how we can clean. Had all of you guys given a neat and nice data, हम immediately data analysis कर सकते थे. कुछ नहीं तो random forest तो लगा ही सकते थे. But now we will spend time cleaning that data, right? और उसके बाद I will try to backtrack which is that person who is making our life miserable की सीधा सीधा डेटा डालने को कहा था, इतना कौन डाल दिया? Okay, good. So the problem was the same. What you dealt with was a smaller data set, and we are also looking at the same solution. We were looking, the other thing which you did not look here was when it said it's 93% accurate. Okay? What was it 93% accurate for? Did it tell 7% of bad wafers were good wafers? Or did it tell 7% of, or good wafers were bad wafers? See the problem? So I have only two types of classification, good wafers and bad wafers. All of you have got an accuracy around 93%, which means there are 7% wrong data somewhere. And because there are only two possible states, which means 7% यहाँ से यहाँ गए होंगे या फिर यहाँ से यहाँ आए होंगे. And there lies our issue now. Because we did accuracy analysis as the broad spectrum. We can do an accuracy analysis just on the ones which are correct. Okay. So what did it tell wrong? Did it tell me that मेरे 7% अच्छे wafer हैं वो खराब थे and I threw them away? Or did it tell me the other way around? The other way around, fine, the customer will be unhappy at me. 7% of my customers will be unhappy. This way I have lost money 7% right in the beginning. And this is why this 93% number is not a good number. So in the beginning it looks very nice. We have got 93% accuracy of predicting at this very complex database. But if you tell that to a manager of a foundry, यहाँ पर हम accuracy expect कर रहे हैं 95% कि yield की कि on a chip a good wafer is having a 95% accuracy और उसके बाद आप कह रहे हैं कि 93% ही हम सही prediction करेंगे. It's not worth risk taking for me. I need better. The other thing which we did in this task was we didn't try to say कि yield कितना है. 60% है, 97% है, 99. We didn't try to tell the figure. We just said कि कौन अच्छा है, कौन बुरा है. And this is why in the other financial data analysis जो हम करेंगे, we will be looking at male versus female. We are not looking कि आप कितना खर्च करेंगे. That will be the harder question to ask. So this is what we did. We looked at 35,000 wafers over a period of 6 months being produced in this foundry. Okay? And I can keep on telling you that there is always a data collection problem. Unless you see it yourself, you don't appreciate it. And you saw it immediately in our financial data collection. Human beings are bad sensors. Sensors also do the same thing. Some data is not always present. It happened because not all wafers were measured because of cost and time. Right? कुछ miss कर गए थे, कुछ sensor faulty data दे रहे थे, तो you remove these things. But we always have this analysis problem with every data you collect. For number of reasons measurements fail कर गए थे उस time में, ठीक है, we can't say electricity failure था, but sensors failure होता है 6 महीने में करीब 100,000 sensors सारे तो काम करेंगे नहीं. The other thing is not every machine delivers the same sensor data. Even if it's being used for the same process step, it could give a different sensor data with a different accuracy, different resolution. And there lies the problem. Almost all the algorithms we deal with want nicely prepared data. Some of you who ran random forest on your own laptop computer, it started complaining that random forest cannot deal with NANs. Okay? And the moment I removed the NANs, मेरे पास कोई data ही नहीं बचा, क्योंकि हर column, हर row में कहीं ना कहीं blank space था. So there lies our data analysis problem. So all computer scientists, all those who do business analysis face with this problem. So the data pre-processing is a vital step in all data analysis and all computer related stuff, and it could take and sometimes even should take 80% of your time. तो हमने जो फाइनेंशियल डेटा कलेक्ट किया उसका कोड लिखने में कितना, हमारा कोड कितना बड़ा है, रैंडम फॉरेस्ट का कितने लाइंस हैं? 15-16 लाइन है मैक्सिमम, इंक्लूडिंग ऑल द इंपोर्ट. सो उसको लिखने में हमें ज़्यादा टाइम नहीं लगेगा नए डेटा के लिए भी, बट इट्स द डेटा प्री प्रोसेसिंग विच इज गोइंग टू टेक अ लॉट ऑफ टाइम फॉर अस. सो दिस विल सर्टेनली सेव हार्ट एक्स लेटर, क्योंकि एक बार जब आपने ट्रेन कर दिया और फिर से शुरू करना होगा, या फिर उस डेटा प्री प्रोसेसिंग के कारण अगर आपको एरर आ रहा है, देन दैट्स नॉट वर्थ डूइंग ऑल द हार्ड वर्क. नाउ हमारे साथ इशू ये है कि आवर डेटा सेट इज बिग. 35,000 वेफर्स. हमारे कितने वेफर्स थे इस टाइम में? 1500, राइट? नाउ वी हैव इंक्रीज द नंबर टू 35,000 वेफर. So you have significantly increased the data. So एक ऑप्शन तो ये कर ही सकते हैं कि we reduce the number of parameters. हमें पता है कि ये वाला टेम्परेचर, डोर का एंट्री टेम्परेचर सेंसर लगा रखा है दरवाजे पर, that's most probably not going to affect. So I can cut down some of these parameters, or I could cut down the number of wafers. क्यों सब में टेस्ट किया जाए, कुछ ही में किया जाए. But we don't know doing what will lead to a loss of parameters for us, loss of accuracy. तो जब नहीं पता हमें, then we can't do that. So after doing a bit of pre-processing, we were left with 323 parameters for the first process step. We looked at 4 process steps. तो आपके यहाँ करीब 450 या 500 parameters थे ना, तो we had 323 per, so multiply that by 4. And then we did a quite a lot of work on wrapper feature selection. So you could do things like principal component analysis to figure out what components might be needed. That also takes time. We used an analysis from a software called R, just because Rebecca loves R. It was a Boruta analysis, and we looked at all these parameters to see which one of them are interesting, which one of them don't lead to big change in output. So of all the columns, some columns will lead to a bigger change, some will not, and some we don't know of. The green ones are the ones which are really vital in producing the output, yellow ones maybe, red ones are less important. So we started removing some of these ones. And to do that, what we were doing, we were iteratively comparing the importance of these attributes and looking at whether this attribute is important or not important. So doing that led to, from 323 we boiled down to 191 columns. Remember, the whole reason we are doing it, we want to reduce the computation time. Jitne kam data hoga utna hum handle kar payenge. So essentially this is how the whole process flow happened. We did Boruta analysis in the beginning, reduced the number of parameters, and then for each parameter we undertook, for each process we undertook the extraction of yield. Okay, good. Let's talk about the results. So आप लोग 93% पर खुश हो रहे थे. Okay. So our first, so these are our obtained yield versus predicted yield value. In an ideal thing, it should all fall on the middle line, right? जो भी predict किया है, जो obtain किया है, that should be. So we're not looking right now on good or bad. We are now trying to regress. हम बताना चाह रहे हैं कि कितना आया. Now you can see where the yield is poor, my prediction is also poor. So if this line is telling me anything beyond this, I'm not put numbers here because not allowed to. Anything beyond this line are good. So this may be X number between 90 and 100. Anything beyond this line is a good wafer. Anything below this line is a bad wafer. The other thing which you can see in this data, there's a large number of goody wafers. There's a small number of bad wafers. So my sheer training data was quite small for the bad wafers. So little wonder I'm predicting badly for the bad ones. For the good ones, I have got decent prediction. Right? I'm very close to the central line. Now in one way, it's not a bad thing. कि यार चीज़ बुरी होने ही वाली है तो क्या फर्क पड़ता है 30% बुरी थी या 40% बुरी थी? It's going to be rejected anyway. Okay? So when it comes to the good ones, we are fairly okay in this. So if you look into our accuracy prediction for the good wafer, we were correct to 99.37%. For the bad ones, we were correct to 97.98%, which means there were 2.1% bad wafers जिनको हमने कहा कि ये अच्छे wafers हैं, and there were 0.6% good wafers जिनको हमने कहा ये बुरे wafer हैं. Now you might think that's fairly good number. That's still 6 in 1,000. We had 35,000 wafers. हमने 6 को खराब बताया. That's 180 wafer threw down the drain. 180 wafer into 10,000 chips is 180,000 chips, which we said which are going to be good, and we said they were bad. Okay, but still much better than what is done. Let's be honest. I mean, this is very good result otherwise. The thing which is actually very bad is the R-squared error. So if you absolutely measure, if this was a predicted accurate obtained result, this is what you predicted, how far what was our error? We are very bad in that, even for the good ones. Look, for example, this we think is good, and we said it's good, but obtained yield was here, and the predicted yield was far away from it. So we have quite a lot of R-square error. Beware, my actual R-square, I have calculated R-square for the entire space, right? Or Rebecca has calculated for entire space, which means there is very high bad error here. So for the bad wafers, my prediction quality is bad, which in turn affects the entire prediction, entire error. अगर error measure करने कितने erroneous थे from all of them. These bad ones increase my error even further. So maybe we should have done a histogram and then said, ये बुरे हैं, ये भले हैं. So this is from a single process step. It's not from, we haven't done the whole chip. ये पहले step से ही हम इतना बता रहे हैं कितने चीज खराब. If I run all the process steps, I can do 99.4% of the good ones and 98.8% of the bad ones, and my R square has also improved. But this meant I had 193 samples of data. Now I have roughly 800 columns of data, right though? And we waited till the whole fabrication finishes before I'm able to predict. So that was the first part. But one idea is to say what's going bad. The other is, if I can now tell which parameter to improve my yield. And that was very tricky. We could try to do other ways. We could try to say, can you tell us the optimal process parameters which will make all the yield better? But then this number of process parameters is so huge that optimality is a very difficult problem to reach. Not just 1 point optimization, it's 800 point optimization. Okay. What we asked the question was in a different way. Let's not try to make कि which parameter, कौन सा parameter yield को बढ़िया बनाएगा. Let's ask the other question. Which parameter will make the yield go bad? Okay? तो अगर हम ये जान सकें कि ये करने से हमारा ये चीज खराब होने वाला, तो let's try to avoid that. Let's we ask the negative questions. Question तो अच्छा पूछा था, जवाब नहीं आया. There is no single optimal value at which the yield became maximum, but if I plot, if my red line is the yield line, what we could say is there are some parameters which are here will never lead something to become good yield. So anything above red line is the good yield, anything below the red line is not so good yield. So ये parameter space जो यहाँ पढ़ रहे हैं, ये कभी असर नहीं करेंगे. They are never able to move my yield from bad to good yield. Make sense? So these were the kind of predictions we could do. Now, आप लोगों के पास भी उतना ही data है, and we were very happy with good and bad. But then comes the next question. ठीक है, हमने ये तो predict कर, how will we improve our process? Okay. Good. I will stop now because we have gone through. Today we went through what process is, what yield is. We then went and did random forest analysis. और उसके बाद we then went and looked at from a research result what happened. Okay. अगर आपके पास time है और आप interested हैं, I will go and look at this data now. On the same sugar folder, I've also provided you some more databases. So an interesting database is, so this I have taken from, I think, Kaggle. This is looking at soil quality, fertilizer amount, and yield per kg per hectare square meter. So it has got only 5 columns and it's trying to predict what happens to the agricultural yield. This will be a regression analysis. So you can, rather than using random forest classifier, you can use a random forest regressor. Or if you're even more interested, this one is a very interesting database which I have taken from, it's a web-based database which is looking at a number of properties. So things like soil color, what is the ingredient in soil, phosphorus, potassium, nitrogen, all the way till, cloud cover and others. And then it is trying to give an advisory note ki kaun si fasal lagani chahiye. So it goes from barley, it's a large database, to maize, to teff. Teff is a grain produced in the Ethiopia region. It produces a very nice bread called injera. And to wheat, and rise. Okay, so it has looked at 4 or 5 different gains. Now, till now we were looking at single object classifier. दो ही bins हैं, good or bad. Now the question then comes, what if I have multiple bins? How do I classify this thing into multiple bins and those things? And also the database here is a little bit, you have got, so 2 things you have to do while dealing with this. So most of this data is nice. It has got numbers. But my prediction does not have numbers. So the quickest way would be to do that. Okay, there are only 5 different types of bins, right? तो उन सबको हम एक एक नंबर दे दें. वीट को 1 कर दिया, बार्ली को 2 कर दिया, मेज को 3 कर दिया. So now I have got groups of 1, 2, 3, 4, 5. I also have the problem in the kind of soil. So this has got roughly, what's the total length of this standard? Roughly 4,000 rows. And then you can dig in these 4,000 rows how many different type of unique values are there. Then go and replace each one of these unique values by numbers. So you'll have these numbers, you will have the data set, and then hopefully you can do a classification just based on 5, and you can also do a prediction based on 5. Now prediction के लिए आसान problem है क्योंकि हम 99.99, 97.23 और 60.12 predict नहीं कर रहे हैं. हम predict करने जा रहे हैं 1, 2, 3, 4, 5, one of these 5 values. So it's a much nicer task than a more complex task. So अगर आपके पास समय है तो these are things which you can try with and do the same thing. The code will remain exactly the same. Okay? Take a certain part of your data set to be the training data set, another part of testing data set. It's just you are working with a different type of data set. The other things are parameter tuning. एक parameter हमने tune किया which was the percentage of data set which we are going to use in training and testing. किस तरह से हम divide करेंगे. If you now go back and look at the properties of random forest classifier, see, you will see what other various option it gives you. And it gives you number of estimators. So this basically says how many, what's the number of estimators we took in our code? Did we give a number of estimators? 10. So 10 से 93% आया था, right? Let's make it 100 and see what happens. And give your test score only to 0.2. So 20% of data are testing. Let's increase the number of estimators to 100. Take it. कुछ फायदा हुआ? रन कर रहा है? What about you guys? It's taking time. नहीं हो रहा है? So we increase the number of estimators and हमारी accuracy prediction थोड़ी improve की. So we can have that. We can go for what's the maximum depth. We can reduce the maximum depth. Right now it's infinity तक जा सकता है each tree. So you can look at these parameters. So इन सबको modify कर सकते हो. Sky is the limit here. So इसको नहीं cover करेंगे आज. Good. So we're stopping today for. I'm stopping from now. I'm here to go and help you guys with this thing. Let's do the analysis of our financial data. Let's also tell you what we will do tomorrow. Should I tell you or should I do it more fun? So मुझे आज बताया गया कि this is presumably a course for you guys. You get credits for it. कितने credits मिलते हैं आपको इससे? अच्छा, that's a political answer. मुझे अभी नहीं पता है. We might have to do a simple quiz tomorrow. परीक्षा लेना पड़ेगा ना कोर्स के बाद, एग्जाम होना चाहिए, नंबर मिलने चाहिए. बट माई एग्जाम्स हैपन इन सच ए फैशन कि आपको जो भी इंटरनेट देखना है, जो भी सर्च करना है, आप कर सकते हो. ओके, सो वी विल यूज द लास्ट आवर फॉर यू टू solve a problem. I don't care how you solve a problem, a simple problem which you can solve based on जो हमने आज किया है. कल हम लोग एक completely different aspect of business के बारे में बात करेंगे. So let's go through. हम लोग start किए थे finance से, right? But we looked at very simple financial data. Then we looked yesterday on किस पर देखे थे हम लोग? Marketing पर, right? तो हम लोग मार्केटिंग देख रहे थे, मैट्रिक्स फैक्टराइजेशन कर रहे थे. सो कल हमने टाइम स्पेंड किया था प्रोग्रामिंग करते हुए. आज हमने बीच का टाइम स्पेंड किया. वी स्पेंड अ लॉट ऑफ टाइम लुकिंग एट व्हाई समथिंग गोज रॉन्ग, और थोड़ा समय हमने बिताया रैंडम फॉरेस्ट के प्रोग्राम करके उसको प्रेडिक्ट करने के लिए. कल हम लोग उल्टा करेंगे. वी विल लुक एट प्योरली बिजनेस डेटा. वी विल लुक एट समथिंग विच हैपन्स ऑन remember I keep on saying the liquidity problem. We'll introduce the problem today and then we'll go back to the financial analysis. So problem lies is this. I do not know how much money I should keep. So आप already एक analysis कर ही रहे होगे अपने data के साथ, और वो हम लोग अभी कर ही देंगे उस financial analysis के साथ. Banks don't know how much data should keep, but this is a very old problem, particularly for banks. जब banks के पास पैसा नहीं होता है, क्या होता है? You guys are doing business studies, right? And only you, so you should know the answer to this question. So if a bank runs out of money, I mean, on an average, what does it mean bank has run out of money? Well done, they don't have liquidity. We are going to actually program for liquidity tomorrow. What does it mean? Tell us to all of us. हम लोगों को तो liquidity नहीं पता है. Okay. So liquid cash, which means it can move. It's not tied. Okay. So what do banks do? They rotate money, right? Let's go to retail. Investment पर जाएंगे थोड़ी देर के बाद. छोटे बैंक्स, right? आप जिसमें पैसे इन्वेस्ट कर रहे हो, तो वो पैसा कैसे बनाते हैं? आपने तो उनको पैसे दिए, वो आपको इंटरेस्ट देते हैं. उनको पैसा कहाँ से मिलता है? हाँ, शेयर परचेज. व्हाट एल्स? सो हम डिपॉजिट करते हैं तो वो हमको इंटरेस्ट देते हैं, राइट? दे आर गिविंग अस इंटरेस्ट. हाउ डू दे मेक मनी टू गिव अस इंटरेस्ट? So they circulate in the economy. Yeah. So they give it to somebody else as a loan or as an investment, right? The problem with loan is you have given a loan to somebody for, say, house building or starting a factory. That person starts or a mortgage. So that person starts giving you mortgage return every month. Agreed? So bank knows for agle 10 saal tak I will be getting this money. But the depositor can ask the money any day. So depositor can go to the bank and say कि भैया मेरा पैसा मुझे वापस करो, right? Now she talked about this. RBI has this number, right? कि आपको इतने % cash रखना चाहिए. But that's just a number learned from experience, right? You're not. Huh. But that is again, you are hoping that this percentage of depositors can come back to me. Unless you have got all your deposit in fixed deposits, aka these will not mature before so long period and you cannot take it back, whatever happens. But even most fixed deposits in India allow you to take money out by suffering a loss, right? So all of a sudden, hopefully, सारे customers मेरे आ गए. I've taken 30% of my deposit as my cash, मैंने रखा है. But 40% of my customers आ गए अपना पैसा वापस मांगने के लिए. The bank needs to take loan from somebody else, और कोई हमको लोन नहीं देगा तो, क्योंकि हो सकता है दूसरे बैंक्स हम पर विश्वास करें कि अरे भैया ये तो बैंक डूबने वाली है, इसको लोन मत दो. So has there been a bank collapse in India? So RBI helps in two ways. Either it can lend money, or it can ask another bank to take over this bank. So has there been a bank collapse in India ever? Or do you know of any? Sorry? Union Bank was running sick for some time. But it was a government bank. So Sarkari bank collapse, Sarkar's collapse nahi karne deti. That's one advantage of this. We'll give you bad service, but as long as the government of India survives, they are the, yes. Yes Bank was there. What happened to Yes Bank? वो इंडियन क्रिकेट टीम के साथ जो भी कंपनी जुड़ती है ना, उसका बंटाधार हो जाता है. Was it Deccan Charges की कोचिन टस्कर्स का चल रहा है ना, कि डेक्कन चार्जेस का भी चल रहा है? ओके ओके, बट यू आर नॉट टॉकिंग अबाउट दिस, आई एम टॉकिंग अबाउट फाइनेंशियल इंस्टीट्यूशंस. सो ये भी एक सिमिलर प्रॉब्लम है कि आपके जो लेंडर्स हैं वो ऑल ऑफ अ सडन आपसे पैसा मांग रहे हैं, और आपने अपना पैसा कहीं इन्वेस्ट कर रखा है, आपको पैसा नहीं आने वाला है, हम कैसे सेटिस्फाई करेंगे? सो सेटिस्फैक्शन का ऑप्शन है कि मैं हायर रेट पर लोन लें हम. सो 2 साल पहले यही चीज यूएस में हुआ था. इफ यू न्यू 4 बैंक्स कोलैप्स्ड विद इन अ स्पैन ऑफ फ्यू डेज. डिड यू रिमेंबर? सिग्नेचर बैंक, ये खासकर कंप्यूटर साइंस वालों को आना चाहिए. देयर इज समथिंग कॉल्ड क्रिप्टो करेंसी. उसके चक्कर में 2 बैंक लुट गए. राइट, दे इन्वेस्टेड हेविली इन क्रिप्टो करेंसी बिकॉज बैंक्स ऑलवेज इन्वेस्ट समवेयर. एक बैंक ट्रेजरी बॉन्ड्स के हाईलाइट में गया. सो इंडिया में पहला कोलैप्स इंटरेस्टिंगली हैपेंड इवन बिफोर फॉर्मल बैंकिंग स्ट्रक्चर वाज देयर. एंड आई एम श्योर कोलैप्स से कोई भी कोलैप्स तो पहले हमेशा हुए जब से लोग अपना पैसा कहीं रखने जा रहे हैं. एंड एज लॉन्ग इट्स नॉट द गवर्नमेंट, इट्स द प्राइवेट सेक्टर, देयर इज अ पॉसिबिलिटी ऑफ कोलैप्स. एवरी इन्वेस्टमेंट इज रिस्की. तो क्या हुआ था कि यूएस में वॉर चल रहा था, यूएस यूके का, राइट. यूके को कॉटन चाहिए. पहले कॉटन आता था यूएस से, तो वॉर के कारण कॉटन नहीं आ रहा है. तो उन्होंने रियलाइज किया कि भैया महाराष्ट्र में कॉटन पैदा हो सकता है. सो ऑल ऑफ अ सडन द कॉटन हियर बिकेम वेरी इंपॉर्टेंट. तो लॉट ऑफ पीपल स्टार्टेड इन्वेस्टिंग इन कॉटन, लाइक बिजनेसेस मैन, बिजनेस हाउसेस, ग्रुप्स स्टार्ट के भी हम कॉटन में. अब इन्वेस्ट करने के लिए हमको पैसा चाहिए. पैसा आप किससे लेते हो? बैंक से. So a number of new banks also evolved who were giving loan for cotton investors, because every year cotton is such a good market, it's giving such a high return, right? And then the war in US stopped and cotton started coming from US. Cotton collapsed, led to the collapse of first big bank from East India Company in India. That collapsed bank की जगह एक और बैंक established किया गया. That later became the State Bank of India. Something similar happened 2 years ago, the Punjab National Bank crisis. Had Punjab National Bank been a private bank and had government said, you know what, you're running a loss, your problem, so they would have declared bankruptcy. So look a bit on bank runs. एक्चुअली एक और इंटरेस्टिंग स्टोरीज में जो आपको, सो स्कॉटलैंड में 2 मेजर बैंक्स हैं, वेल 3 बैंक्स हैं. बैंक ऑफ स्कॉटलैंड, रॉयल बैंक ऑफ स्कॉटलैंड और क्लाइडस्डेल बैंक. इट्स अ वेरी इंटरेस्टिंग फाइनेंशियल इंफ्रास्ट्रक्चर देयर. सो इंडिया में नोट कौन छापता है? हु मिंट्स द कॉइन्स? द गवर्नमेंट. दैट्स अ वेरी गुड. सो आरबीआई ओनली प्रिंट्स नोट्स, राइट? व्हाट डू द नोट्स से? Have you read what does the note say? Do you have a note with you? Okay, आजकल नोट लेके नहीं चलते, अब सब डेबिट कार्ड पर है. तो read what does the note say. There's एक सिग्नेचर होता है रिजर्व बैंक ऑफ इंडिया गवर्नर का, उसके पहले एक स्टेटमेंट है. What does the note say? हाँ, हिंदी में भी लिखा, अंग्रेजी में भी लिखा होगा. हिंदी में पढ़िए. हाँ, ये कौन? नहीं, इंग्लिश पढ़ो. इट्स ए promise. It's a promissory note. हाँ, क्या हिंदी में क्या है? का वचन देता हूं, राइट? कम से कम वचन इज मोर इंपॉर्टेंट देन प्रॉमिस. नाउ गवर्नमेंट ब्रोक दिस प्रॉमिस रिसेंटली, राइट? 2000 रुपए के नोट के साथ प्रॉमिस ब्रेक किया था ना. एंड दिस इज व्हाई वी कांट डिफीट द गवर्नमेंट इन कोर्ट, बिकॉज इट वाज अ प्रॉमिस, इट वाज नॉट अ लॉ. हमने आपको प्रॉमिसरी नोट दिया था, नहीं मिस कर रहे हैं, जाइए, अब क्या कर सकते हो आप. सो इंडिया में नोट छापने की कैपेबिलिटी सिर्फ रिजर्व बैंक ऑफ इंडिया को दी गई है. ओके, बट इज देयर एनी रीजन टू डू दैट? क्यों दिया गया? कोई और भी तो छाप सकता है. लोग अपना प्राइवेट नोट भी चलाते हैं. आपने कभी प्राइवेट नोट नहीं देखा है? तो जब किराने की दुकान से व्हेन यू बाय थिंग्स और समथिंग मिस हो जाता है तो एक छोटे पेपर पर लिख के दे देता है कि सर 200 रुपया बचा है, अगली बार यूज कर लीजिएगा. इज दैट नॉट ए प्रॉमिसरी नोट? द वर्ड नोट कम्स फ्रॉम दिस कॉन्सेप्ट कि हमने हाथ पर लिख के एक नोट दिया आपको कि इस नोट से ये कीजिए. दैट्स हाउ द नोट, बैंकिंग करेंसी स्टार्टेड विद द नोट. ओके, सो वो भी एक तरह से नोट हुआ. Agreed? So the question was, why does Reserve Bank? So in India we only have one bank which issues the note, and that's the legal tender. In England we have Bank of England. In Scotland there is no single bank, even though Scotland is part of UK. Historically, financially वो अपना खुद चलाते थे. So वहाँ पर हर बैंक अपना नोट छापता है, and that becomes interesting, isn't it? तो 3 मेजर बैंक्स हैं और तीनों अपना अपना नोट छापते हैं. Scotland is a very small bank area, right? So the interesting part is this. You will have, if I can say Scottish notes. So you see, you will have different note series, different. So there will be a note of Royal Bank of Scotland. There will be a note, let's see, RBS, POS. Why can't I get all the pictures at one go? These are all the Royal Bank of Scotland notes. So you know what? Source of every knowledge. Still bank notes. So this is the Bank of Scotland £5 note. Okay, and in the same country we have a Royal Bank of Bank of Scotland. This is a Royal Bank of Scotland. Same country we have a Royal Bank of Scotland note. Okay, so these are exactly the same value note in the economy, and then there's a Clydesdale Bank note. Okay, to make things interesting. वो थोड़ा छोटा है, बट वो अपना नोट खुद डिजाइन करते हैं वो भी. तो आप जब एडिनबरा या ग्लासगो जाइए तो फॉर यू कैन बी रिटर्न्ड एनी वन ऑफ दीज 3 नोट्स अगर आपको £5 चाहिए. ओके, आई थिंक डॉक्टर मुखर्जी इज हियर, वी विल स्टॉप नाउ. सो इंटरेस्टिंग स्टोरी इसलिए है, इज नॉट व्हाट इज द करंट स्टेटस, व्हाट इज द हिस्ट्री. सो रॉयल बैंक ऑफ स्कॉटलैंड पुराना था और बैंक ऑफ स्कॉटलैंड जब खुला तो उसने अपने नोट छापने शुरू किए. तो इनको चाहता है कि हम उस बैंक को बैंकरप्ट करें. तो ये क्या कर रहे थे कि मार्केट में जाके उनके सारे नोट्स खरीद ले रहे थे. राइट, आपके पास बैंक ऑफ स्कॉटलैंड का, वो मुझे दे दीजिए, मैं आपको आरबीएस दूंगा, ताकि मार्केट से उनके नोट ही गायब हो जाए. और फिर उनका प्लान था कि एक दिन सारे नोट्स ले जाके बैंक ऑफ स्कॉटलैंड को एक ही दिन में देंगे कि भैया हमें इक्विवेलेंट वैल्यू दो, and that's the way bank will go bankrupt, right? It can't meet all its printed notes के पास. अगर सब लोग RBI के पास एक ही दिन चले जाएं कि हमें इस नोट का इक्विवेलेंट वैल्यू दो, whichever you currency में हो, RBI can't give that. So that's called a bank run. कल हम लोग बैंक रन से शुरू करेंगे and then we'll go to corporate liquidity. How can we predict that based on some sort of neural network estimator? Sorry, बिना मतलब के 15 मिनट हम कल के लेक्चर के बारे में बात करें. Such an interesting story of banks and this thing. Okay, financial data करना है कि आप लोग थक गए हैं? इस डेटा सीरीज का क्या किया जाए? इतनी मेहनत से डेटा कलेक्ट की और 2 लोग हमारा डेटा डिस्ट्रॉय कर रहे हैं. So, generally what we will do is if we have a financial data like this, we will try to write a code to go around and manually and change these things. But because हमारा data series छोटा है, and to be very frank, there's only one data element, which is guru, जो हम सबको चेला बना रहे थे, which is a bit problematic. बाकी सारे we figured out this number is not 1000, is 12,000. Okay, so we have this number somewhere else. So one option could be कि भैया manually edit कर देते हैं इसको. ये तो कर ही सकते हैं. एक ही डेटा सेट, एक डेटा सेट के लिए क्या कोड लिखें? तो if there is just one or two, either manually edit करें or we remove this data set. So that's one thing. Some of them have given us 2023 data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 people have given us 23 data as well. So now that makes a strong case to use 2 years data. And random forest जैसा हमने apply किया online can look at not available data as well. At least the Google's implementation. Okay. Then comes these things. We need to give numbers to these. Okay. तो I'm sure we can come up with a number for in hostel के लिए 1 लगाए, इसके लिए 2 लगाए, and so on so forth. And same with these, we can come up with a weighted number here. So every week के लिए once कर दें, 2, 3 times. Often frequent. Spider-Man. Well, जरूरत पड़ती है Spider-Man को यार. No. And then there is. So the funny thing is this: if you look at this data and cross correlate the gender with how frequently do you eat outside, we have got 5 times man, often frequent man, girls are every week, 2, 3 times a week, 3, 4 to 4 times men, 5 female. Actually there is no considerable statistics. They both pretty much eat the same except there are कुछ जो घर का खाना ही पसंद नहीं करते. So we will, you have all this data with you. So you have, I've shared the entire database, right? तो आप खुद से इसको देखिए. See if you can just edit this one person, one problematic person. और उसके बाद पता लगा ये who the hell is this guru और उसकी पिटाई करेंगे रात को. You know. ये तो सारा मेरा एनक्रैपमेंट का यही कदम कर दिया. If you know, you keep it secret. I promised no such financial information will come out, and this will not come out. Okay? And then let's see अगर हम लोग random. So अब हमारा क्या होगा? Which will be my output column? Which column is my output column? It's no more the last column. अभी तक जो data analysis कर रहे थे, last column was my y. अब मेरा y को क्या होगा? So my your gender column will become my output. And so अब हम जब remove करेंगे तो इस your gender को हटाएंगे. The other thing, remember, it also has got timestamp. So when you read this data as a CSV file, do not forget to put date parts dates to be true. Name को भी हटा दो, name से कोई फर्क नहीं पड़ता. I don't think we can figure out from Spider-Man कितना खर्च करते होंगे, right? It's very difficult. Okay? और okay, this was my spelling, right? Parents की जगह parents बना दिया मैंने. So majority of them live in hostel. That would be interesting to see, just as a manual analysis. Do those who live with their parents spend less? Hostel का खर्चा नहीं देना है, right? So how do we then? So we know other people are doing hostel खर्चा और गुरु भाई सबका अलग अलग लिखे हैं, right? Family visits और vacations, हर महीने में उन्होंने कुछ और किया, फिर मोबाइल भी रिपेयरिंग करवाई, भैया सबका खर्चा एक साथ डालना था. So what do we do? Sure. What do we do for such data where we have got a small group of people who live with their parents and hence don't have the accommodation expenditure? Do we treat them as it is with all other people who have got their accommodation expenditure? Or do we boost their data with an average value of accommodation to bring it in line with us? Both options should work. So you can find what's the average cost of accommodation for everyone else. Okay. So I'm not going to intervene in this. This में और sugar analysis में बिल्कुल intervene नहीं करूँगा. You wanted the data, you have the data. If you can't do anything, then tomorrow evening I will write my own code. But अभी आप जाके edit कीजिए. Now this is a comma separated file. Sorry, the expenditure data. So how will we read the expenditure data? So दो तरह के solution हम कर सकते हैं. So if I save this file as a CSV file, so everything else will be comma separated, और ये automatically comma separated है, and when I read it back, it will automatically come in 12 columns. There's a reason I asked all of you guys to enter in comma separated. Okay? Problem वो उनकी होती है जो already इस अपने data को 12,000 के बाद 12 के बाद भी comma लगाया उन्होंने. So अब come up with a strategy. How do I read that data so that I don't do a mistake there? So what can I do to read this data such that I do get ideally I should process it before I convert it to a CSV file, right? So there can be many strategies to do this. Oh boy. One thing we could do, we could parse the data, and wherever we see 3 zeros together, we club, we delete the comma before that. Manual parsing करके कर सकते. We could write a code which just looks for, or we could enter the entire thing in a string. It's not a very long data. Look for 3 zeros. Wherever 3 zeros exist, remove the comma before that. Okay, that is one solution. The other solution is, sorry, you could. The other solution, oh my apologies, could be to, so it is the Excel translation which is causing concern here. I can actually get the raw data and put it there. Now let me just check with the raw data if anyone has put a decimal digit, because that will be more tricky. So हुआ क्या है ना कि जब हम Excel में transfer किए इस information को, so Excel has thought this is a number. Okay, so now I have saved one of the last person. The number is 12800, comma 22200, comma 1700. So Excel has just thought it's a huge number. Those who have not given a space, it has just combined them to be a big number. Okay? So all these problems exist. You have the raw data with you, and I don't think anyone has put any. Oh no, okay, fine. This is perfectly fine data for you to play with. There's only one person who has given answer to the closest 15 पैसे 5,935 रुपए 15 पैसे. That girl is going to join a bank. I can see if, is it a boy or a girl? First, sorry, I have to check that first. ये आ रहा है just before Guru. Who is just before Guru? Just after Guru. Sarah. So she has got this really good accounting system. Good. So data आपके पास है. This is much smaller data than the sugar data. We have got enough data to play with. Come up with something nice and then let's come on, see if you can predict men and women, or if you can do data series analysis. And you know what? मुझे परीक्षा लेने को कहा गया आप लोग का. Let's do this as the exam. You are free to do whatever you want. Okay? उसी पर grading करेंगे. Good. I will stop now.